Thank you, Andreas, for the so kind invitation, and congratulations on this beautiful program that you've been setting up. I must admit I very much appreciate the holistic approach you are putting in sustainability, because you're looking at the use of Earth resources, the use of Earth orbits and the Earth orbits, and thinking that humanity has been using space and exploring space for more than 60 years now. We've just celebrated 2 weeks ago, a bit more, the first flight of Yuri Gagarin. It was on the 12th of April, 1961. So more than 60 years later, we are witnessing very fast developments in the use of space, especially in the use of low Earth orbit, with a large number of satellites being launched in the last years, much more than in the last decades. And that this increase, this acceleration is raising a lot of questions, obviously, a lot of new possibilities, but also some questions pertaining to how we organize this, govern this, what rules should be in place so that all these new activities can be sustained on the long term. So I very much welcome this comprehensive approach, also because there is an angle which is not very often addressed in the realm I'm often working at, and that is at the UN. But you have, Andreas, you bring also an ethical reflection, a philosophical reflection into this, the approach, your approach for planetary sustainability. And I believe this is very much important to keep this in mind, and to get to keep the reflection on how humanity is going to further explore space, where there are now projects to go back to the moon, to install a station which should be inhabited by humans on a permanent basis on the moon. Same plans maybe which will for further in time, but to go to Mars also with humans. So it's all those fantastic projects need to be accompanied by a philosophical reflection, an ethical reflection, to keep in mind what and maybe take the lessons of how humanity has been using the Earth and how it will use the cosmos, if I may say so. And maybe just a little. I thought I would be short, but I'm speaking already quite long. Just wanted to give you a slight view, since I'm presently in Vienna chairing the scientific and technical subcommittee of the UN Committee on the Peaceful Uses of Outer Space, where several topics which pertain also or are relevant to the topics of today's workshop are being addressed. And I'm thinking, for instance, of the use of, as I was mentioning at the start, of low Earth orbits by large constellations. For instance, here in Vienna this week, discussions are taking place among member states, which are 95 member states, including all major spacefaring nations. And they started discussing the impact of large constellation on astronomical observations from the Earth, and also they may at some point start discussing how to address the important use of specific orbits with a lot of space objects. So And here I'm referring to the launch of the new working group on the long-term sustainability of outer space activities, for which hopefully the election of the new chair of this working group is going to be confirmed in the next 2 days. So you see that the topic you're addressing, and you will be addressing the whole day today, is very actual, is very relevant. And I would emphasize again, it is needed it is for states, the intergovernmental work, it is needed to have a philosophical reflection, maybe a more academic thinking about how we use space and how we can, what we can do to use space in a sustainable manner on the long term. So with that, I will close my introduction and thank you again for the invitation, and wish you a very interesting day, a lot of success, and I look forward to reading the report. I will not be able to be with you today because I have this commitment here in Vienna, but I very much look forward to hear about the results. Thank you so much, and have a very productive and interesting day. Thank you.
Thank you so much, Natália. Do you hear me? I have to check because my screen is so partially frozen.
I do hear you very well.
Okay.
Thank you.
Yeah, thank you so much for this encouraging and well, visionary remarks. And well, now it's time to start with the first presentation. As
I'm gonna do it a little bit. Can you see the title slide of our talk?
Yes, we see it perfectly.
Looks nice.
All right. So with this shortcut, I also welcome all of you from my side. My name is André Galli from the University of Bern. I've been working together with Andreas and now Xiao-Shan about this concept of planetary sustainability. Since I'm a space scientist, my angle is the perspective of a space scientist. And I've been discussing these issues about planetary sustainability. What does it mean within the space community over the last few years? So here I'm going to present you where we at the space community stand with planetary sustainability and these questions pertaining to ethical questions, policy about the exploration, research and usage of outer space. In terms of the scientific community, the natural place where such questions have been discussed for decades is COSPAR. COSPAR is the Committee on Space Research for furthering research, exploration, and the peaceful use of outer space through international cooperation. So there are COSPAR assemblies every second year where space scientists from all over the world gather and exchange ideas and of course also research. But there are also several panels that discuss policy-related things that have to do with space research and exploration. For many decades, basically since the start of the space age, COSPAR has been maintaining not only the goals, but also the formulation of planetary protection, for instance. And COSPAR continues to do so. With planetary protection, the goal is to avoid organic constituent and biological contamination in space exploration. That's well defined, and all major space agencies around the world have subscribed to this policy, and everybody agrees it's very important. But it doesn't stop there. COSPAR has also panels that engage in the broader effort of a general environmental stewardship for celestial bodies and for outer space. This panel at COSPAR is now firmly installed, and also at the most recent COSPAR conference this January, there was a session and also a business meeting of that panel where I and Andreas also participated in. This panel addresses a wider range of concerns related to space research and exploration. And as I said, we gave our input presenting the concept of planetary sustainability in this panel, and we keep working in this panel so that ethical questions and all other questions related to policy making for the environmental stewardship on celestial bodies come together. We presented this helpful tool for such a framework at the COSPER conferences in 2018 and now at the recent conference. And if you wonder what is actually planetary sustainability, this would have been the part of Andreas, but I'm just presenting this slide very briefly. Planetary sustainability is sustainable development, as stated in the Brundtland report, plus 2 recognitions. The Brundtland report from 1987 means as development is sustainable if the present generations can meet their needs, while also future generations will be able to meet their needs. So it's all about thinking what resources are available and not to use up more resources than we can yeah. So sustainable development plus 2 recognitions. We must recognize that Earth is a planet, so we must respect the boundaries of the Earth system. You have heard a lot about the planetary boundaries that are important when you talk about development here on Earth, but also about capacity of ecosystems, climate change, the nitrogen and carbon and the phosphorus cycle. We must respect the boundaries of the Earth system. That's one of the frameworks that have to be kept in mind for this planetary sustainability. The other important thing is that sooner or later, without expansion of people and our instruments, our technology into space, humanity can or will conceivably perish. This might happen, in many millions of years when the sun gets warmer and warmer, but it could also already happen before due to a disaster. So planetary sustainability is sustainable development, as usually understood, plus those 2 recognitions. And we are in favor of actually adding the space environment as an 18th goal to the UN Sustainable Development Goals. The normal UN Sustainable Development Goals for 2030 just contain those 17 goals here, and we're in favor of adding an 18th goal. We have been discussing these questions with the space community among COSPAR assemblies, and there was a unanimous consensus among space scientists that outer space has an important role to play for a sustainable development here on Earth and also beyond. And the majority of space scientists polled were actually in favor of adding outer space as an autonomous 18th goal to the existing sustainable development goals of the UN. There are 3 main areas of immediate concern: space debris, or we could say satellite orbits, the moon, and near-Earth objects. These are of immediate concern because they are closest to us, and here there are a lot of ideas by space agencies and also by private actors to make use of those spaces and of those objects in the near future. When we talk about asteroid mining, when we talk about maybe, for instance, tourism on the moon or moon villages close to the poles. And of course, space debris is a big issue also because of the increasing satellite traffic. We published this first study in 2019 in Life Sciences in Space Research. this is my last slide, and then I hope that Andreas or Xiao-Shan can take over. The new developments over the last 2 years are the following. Planetary sustainability has gained even higher urgency in the eyes of researchers because of satellite networks and their knockoff effects, in particular for radio astronomy. We heard also Natália Archinard mentioning this. That's really, those are ongoing discussions. And of course, there's the planned return of humans to the moon. That's the Artemis mission planned for 2024. Maybe it will be delayed a little bit, but it should come to pass over the next few years. The COSPAR panel on exploration has existed for more than a decade, but the terms of reference are being updated now. And then I invite everybody to have a look here at the public website of that COSPAR panel. And within the space science community, COSPAR, and there in particular this panel on exploration, is the obvious, or I could even say the natural environment to initiate and continue the discussion on planetary sustainability and related ethics and policy questions. And this panel, let me close with that, attracts more and more participants as the years go by. And at the next COSPAR assembly, we will organize several sessions. So we might say that the topic of planetary sustainability and ethics really has entered the mainstream in the space research community.
Great. Thank you very much, André. We are very sorry that we have some issues from the side of Andreas, but perhaps let me take this opportunity to shortly introduce myself. I am part of the organizing team. I am a research scientist based at the Environmental Social Sciences Department at EAWAG in Dubendorf in Switzerland, but I am also a guest assistant professor at Utrecht University. So among other topics that I've looked at, I have increasingly drawn to the topic of space sustainability, which I call as Earth space sustainability, and I will share my research plans and agenda with you during one of the presentations this morning. So today, I am supposed to co-moderate the afternoon session, but also the closing panel. But I guess right now, because we are just a few minutes away from the next presentation, so I would like to ask if we could see, Andrea, would you be able to see any questions from the floor? I am a little behind here. Otherwise, I would suggest that we could also just go ahead with the presentation of Christian.
Let me have a brief look at both the Zoom chat and also at the event chat on the Space for Impact website. Currently, I don't see any new questions here, and we already mentioned it before, but I'll say it again. If you have any questions or comments, please enter your comments or questions into the event chat on the Space for Impact platform.
Okay. So if there's no question, I would suggest that let us move on to the presentation of Christian Berg. If Christian, you are already with us. Okay, good. All right, so yes, Professor Dr. Christian Berg, he has extensive professional experience as sustainability lecturer and keynote speaker for corporate sustainability. Among others, he worked as Chief Sustainability Architect at SAP and led the task for sustainable economic activity and growth within German Chancellor Merkel's Future Dialogue. So I would obviously, we know that his book, Sustainable Action, Overcoming the Barriers, was accepted as the new report to the Club of Rome. I will not talk more, and I would already give the floor to Christian. Please go ahead.
Thank you very much, Xiao-Shan. Can you hear me well?
Yes, we can hear you very well.
And see my screen as well?
Yes.
Perfect. Yeah. So thank you very much for the introduction. And I'm really sorry for Andreas that he cannot attend at the moment. But let's hope that he can join soon. Yeah, ladies and gentlemen, it's really an honor and a pleasure being here with you. And let me maybe add to the introduction one personal comment. I started my studies actually with physics and with astrophysics, and I did a master thesis, a German diploma, and I wrote a thesis on the dynamics of satellite galaxies moving in halos of dark matter. That was already almost 30 years ago. But nevertheless, so I'm have much appreciation for astrophysics and space science. This image, which you can currently see, is obviously the rising Earth over the moon's surface, which was taken from Apollo 11. An image which André also used in the previous lecture. The one astronaut who presumably took that picture and passed away yesterday, as we could listen from the media. This image has become so important. The Earth over the rising Earth over the moon's horizon half a century ago, and has become a metaphor for our endeavor as humankind. It has become very influential in the environmental movement ever since. Humanity lives on a finite planet in a very limited environment with limited natural resources and limited ecosystem capacity to absorb the leftovers of our industrial metabolism. Despite the rise of environmental concerns some 50 years ago, humanity is still proceeding on a path which is anything but sustainable. In fact, our generation has a very special position within humans' history, since we are at a critical turning point. As the former General Secretary of the United Nations, Ban Ki-moon, said in 2015, we are the first generation that can end poverty, the last that can end climate change. Within my own granny's lifetime, the population on this globe has quadrupled. Our raw material consumption has grown by a factor of 8, and our energy consumption by a factor of 10. This has never happened before, and I dare to say it won't happen again at any future date, that within one person's lifetime, you see a development of these parameters in such a drastic, with such a drastic growth. Evidently, unlimited growth does not exist in nature. It only exists in math and maybe in the imagination of some economists, but in the real world, unlimited growth is not possible. And this was the maybe not so surprising result of a famous report, which has become, or which was the first report to the global think tank, the Club of Rome, of which I'm proud to say that I'm also a member. The Club of Rome was established in 1968 and founded by the Volkswagen Foundation. There was a project at MIT which used a world model of J. Forrester and did computer simulation, and remind or be aware of that this is 50 years ago. And the final report of the computer simulation of the development of humankind was accessible for a broader public in this famous book, Limits to Growth. And I want to quote here from that book. If the present growth trends in world population, industrialization, pollution, food production, and resource depletion continue unchanged, The limits to growth on this planet will be reached sometime within the next 100 years. The most probable result will be a rather sudden and uncontrollable decline in both population and industrial capacity. And the British Guardian concluded in 2014, so after quoting this phrase, so far there's little to indicate they got that wrong. So despite all the criticism, and some of that might be actually fair, but despite all the criticism which has been raised against the main thesis of limits to growth, its core idea or core conviction is still valid. And if you look into the details, the studies, I should first say that limits to growth did not do any prediction of the state of humankind. It was scenarios that were outlined. There was a business as usual, a bow scenario, and there were other more pessimistic and more optimistic scenarios, and the standard run, which means if everything proceeds as usual, is illustrated here and compared with the data from 1970 to 2000. And you can see that for a number of indicators, there is actually a quite good match. Now, 3 decades later, Paul Crutzen, the Nobel laureate from the Netherlands, who worked in Germany as a chemist, coined the phrase the Anthropocene, or actually I think it was suggested even before Paul Crutzen, but he had a paper in Nature called Geology of Mankind, and there he suggested to call our present era the Anthropocene, because the human influence on this globe has become so important or so dominant that that even in geological terms, the dominant influence on this globe is humans. And if you look into the history of the atmosphere, you can see that we have a remarkable stability of temperature during the Holocene. Here you see the last 100,000 years and the isotope 18O, which is a proxy for the temperature. And you see on the right-hand side, you see the delta in temperatures, and you see that within the last 100,000 years, there were significant changes in temperature within a few hundred years, maybe even a few decades. And only in the Holocene, we have a very, very stable temperature. And now, as we all know, this has changed. And here you see in this image, you see the last 10,000 years, the CO2 concentration, and you see that we are currently really going through the roof, literally. So this means we are literally going full steam to irritate this delicate balance in our climate system. We have changed the CO2 concentration by 50% since pre-industrial times. Another image from space can again illustrate the fragility of our atmosphere. Down here, the atmosphere seems endless, simply because we are basically living in a two-dimensional environment. As humans, we have no sense of a three-dimensional, of the third dimension. Everybody who is climbing a tree and seeing how high actually 3 or 4 meters can be, can sense, knows what I'm talking about. But from outer space, you can realize that it's actually like a very thin film coating the Earth, the atmosphere. The troposphere, which means the first roughly 11 kilometers where most of our gases are located, extends to just 1 per mil of the Earth's diameter, 1 per mil. So, you know, we long talked about the ozone layer and the depletion of the ozone layer. And I think most of us, or most of the speakers at least, will know that if you compress the entire ozone, which is in the stratosphere between 15 and 25 kilometers, if you compress that to normal pressure, it will be a layer of just 5 centimeters maximum. So regardless, this small amount, the ozone layer, is so incredibly important for basically protection of life. Australia has the highest skin cancer rate on the globe, of course, because of their white skin and because of their leisure activities, but also because the ozone layer, the ozone hole was increasing the ultraviolet radiation. So the concept of planetary boundaries, which was already quoted in the previous lecture, which was introduced by Johan Rockström and Will Steffen and others from the Stockholm Resilience Center some 10 years ago. This concept means that we have a safe operating space in which we as humanity can live and can operate. And there are certain areas, certain indicators where we are in danger of going into a risky or maybe even a devastating domain. And you can see here that in the inner part, we have this safe operating space. And the more we move to the outside, the higher the likelihood gets that we exceed planetary boundaries. That means that we reach, that we step into an area where the likelihood for irreversible devastating developments increases. And contrary to the public perception, the scientists say that this is quite likely not even the worst case in the climate change, but the biosphere integrity, the extinction of species, and the biogeochemical flows of nitrogen and phosphorus are potentially even more devastating or more risky. And if you look at these images here, you see that we have really a problem with eutrophication, which is related, of course, to the biogeochemical flows of phosphorus and nitrogen. We have doubled our nitrogen input to the environment since the 60s, and we have tripled it for phosphorus. And this is not just taking place in one region, it is all over the globe. In the coastal zones of many rivers and deltas, we have similar situations. And regarding extinction of species, we are basically pushing, or literally pushing away wildlife. And the current pandemics can also be partly, at least, seen as a result of this close, this proximity of our human and our wildlife, because we have basically pushed away the wildlife. 10,000 years ago, before humans settled, the weight, the physical weight of all humans were roughly 1% of all higher vertebrates, wild animals. Today, all humans sum up to 1/3 of that weight, the livestock 2/3, and the wild animals 1/3. So, 1%. So 1/3 humans, 2/3 livestock, and roughly just 1% is still the weight of all higher wild animals. Which leads, of course, as a consequence, to a mass extinction of species, as we are all aware. Despite all progress in space flights and the fascinating news from astrophysics and astrobiology, we can say we have our spaceship Earth, which we need to protect. Now, I'm sure we all are aware that, and this was already mentioned by André, that in this community, there is one addendum to the to the sustainability definition, and that means we need to move to outer space in order to secure life ultimately. And one of the most famous proponents of this view was Stephen Hawking, of course, as he said, humanity will likely not survive another 1,000 years without escaping beyond our fragile planet. And we also know that there were already plans to colonize Mars some years ago. And actually, I think it should have started around this year or next year, I'm not quite sure, with actually a one-way ticket. So colonizing Mars, actually, I wouldn't volunteer for such an endeavor. I think it is a pretty risky and pretty extremely risky attempt at this stage. On the other hand, it's quite likely that within 1, 2, or 3 decades, such things can certainly be possible. But I assume we have a common understanding here in this group that we cannot expect that colonizing space will be by any means resolution to our kind of messy situation in our ecosphere on Earth. These two issues, the miserable condition of our natural habitat and potential future colonies in space, are totally distinct topics. In my view, in any foreseeable future, I do not see colonizing space as any answer to cleaning up our home planet. As a trained astrophysics, as I said before, and enthusiastic amateur astronomer, I'm fully behind space research and space flights. But I think we need to be careful not to leave the impression to the public that it's already too late to save the Earth, and therefore we should rather invest in colonizing space. A quick look into the numbers can strengthen my point. One of the candidates for being colonized is the exoplanet TRAPPIST-1d, with a distance of 41 light years from Earth. And the object, which is a human-made object, which has meanwhile reached the most distance from the Earth, is Voyager 1. Within 40 years, Voyager 1 traveled 19 light hours at a speed of 17 kilometers per second, which is roughly from London to New York in 5 minutes. And it would still, for Voyager 1, would take 800,000 years to get to TRAPPIST-1. So even if we deep freeze the astronauts, there is hardly any chance that if we don't see any really significant improvements, that we at one state in time can really colonize such an exoplanet. So can space science, space flights and astrophysics help us facilitating maybe an understanding of the distinct peculiarities of humans' precious and fragile habitat? By 2050, if we continue with our current consumption of resources, we'd actually need 3 Earths to meet our demand. But of course, we have only one. And therefore, it is important that we use all measures we have to make people aware of the special condition we have on this globe. Obviously I have never been to outer space, but I can imagine that if you look on the Earth from outer space, you realize how precious, paradise-like our environment still is. There is so much magnificent and beautiful dependencies of all the living organisms, that it's really marvelous, and that we need to protect this. And I want to conclude with actually a small video from which Alexander Gerst, the German astronaut, produced a few years ago. I think I need to stop that first before I can share here. And please respond if you can see that. I hope you can hear it now.
The name Blue Dot was inspired by one of the iconic images that the Voyager probes took several years ago when they were on the way out of the solar system, but looked back on Earth and took a picture of basically the black sky with a tiny little blue pixel being our Earth. This shows us how fragile this planet is and how lonely it is in space and how much we need to take care of that. We chose that as our mission name and our mission motto. We have designed the logo of the Blue Dot mission in a way that it represents a blue sphere, meaning Earth, as a spaceship that travels around the sun once a year with us humans as astronauts on board. So there's also a little iconic image of the Earth in the patch, which is protected by two hands holding it, which is supposed to show us that it is important to take care of our fragile Earth and that we better not destroy the only spaceship that we have.
So, half a century after Apollo 11, the images of the globe from space are no less impressive. And I think they can stimulate the awareness of the fragility of our cosmic habitat, maybe even stronger than before, because of the mess we have produced meanwhile. As Alexander Gerst has so enthusiastically expressed, we really need to get to an awareness how precious and how extraordinary fine-tuned our systems are, and that we really need to make sure that we protect our cosmic home. Yeah, I think that's it, what I wanted to share, and I'm looking forward to your questions, and thanks for your attention so far.
Thank you, Christian, for the very fantastic talk. We would like to proceed with the questions. I'm not sure, Andrea, would you like me to pick up the questions from the floor, or would you like to go ahead?
No, sure, it's good. We have a few minutes until you're scheduled to talk anyway. So the first question was came in by Hubert Meisinger, I think. He's asking, what do you think, Christian Berg, about the donut model that does include societal, that does include societal aspects to planetary boundaries?
Yeah. Hi, Hubert. Good to hear from you. Yeah, I think that is, it's absolutely critical that we include societal aspects. It's obviously not, sustainability is not just green, you know. It was already at the Rio conference in 1992, humanity has become aware that we cannot just protect the Earth and the ecosystems without development. So these two belong together. And I think for quite long, we have missed that sustainability can only be reached in an integrative way. I mean, the climate issue is very serious, but we have not we have listened to the climate scientists, but have not and have maybe studied and explored the social implications of changing climate, but not so much the social conditions of protecting the climate. So what do we actually need to do in order to get people behind the idea that we need to do something? And if I may quickly show again here one book I recently published, which was mentioned in the beginning. In that book, which is basically appeared in both German and English, in that book I illustrate an approach where we go within a systemic way to address what I call barriers to sustainability. And it is absolutely clear that we need to include this social dimension. We need to find an answer how we deal with populism, how to deal with fundamentalism, how to deal with social inequalities. If we do not resolve these issues, we will neither resolve the ecological issues.
Thanks a lot. We can move on to another question. There were actually several of them. Let me see. The next question came in from Michael Klorman. He is curious how we can societally translate outer space sustainability or planetary sustainability, as many of these metaphors and examples that really impressively illustrate planetary limits may not work for the seemingly limitless outer space. So how can we break the myth of unlimited cosmic scales? So he says he's working on those questions himself, so he would be interested in your take on that. So if I understand this correctly, that there is this idea of okay, Earth may be limited, but outer space is completely unlimited. It's so vast and huge. So so no boundaries. No boundaries apply to outer space.
Yeah. I mean, this was, I hope I understood the question correctly. If not, please ask again, or also send me an email later. We can follow up one by one. I tried to make my point with the spaceflight example. I mean, let's assume we can even travel at one point in time with 90% of space of light speed. Even then, it would, to the mentioned exoplanet TRAPPIST-1, it would take 80 years back and forth. And within 80 years, at least under current conditions, most of our friends and family members will have passed away. So even if there is, and this is a theoretical, a physical boundary, which we will probably, I think, never move beyond, even then it is really insane to think that we can colonize the universe and get back to Earth, maybe, you know. That what maybe is more in focus here in this community is how we use the resources of maybe other planets, or for our development on Earth. I mean, that's a bit like thinking that if we only switch to electric vehicles, then all will be fine. I mean, that's naive to think. I think our consumerism is not just the problem, it is merely a symptom for our kind of desire to ever more consumption. I'm really much influenced and impressed by Erich Fromm, who said some 60, 70, 80 years ago that consumption is actually just a proxy or a substitute for a satisfaction which we are missing in other areas of life, in other aspects and other dimensions of life. And here, Viktor Frankl is pretty close to him in saying that it is the quest for meaning that humans are driven by. And if we don't find a solution for that, an answer to that question, then we will not be able to address the prevailing consumerism. I hope that goes into the direction which brings sense to you. Otherwise, please ask again.
Thanks a lot. And this actually also might partly answer a question by Loy Miro, asking, as reader of Limits to Growth, enjoying this talk, thanks a lot. The same mechanism that that is driving humanity to transgress planetary boundaries and leading to reach limits to growth, overconsumption, and so on, maximization of profits, are also, and that's not the main point, are also more and more powering space activities like you know, the rise of commercial space industrialization. And so then I think the suggestion is that democratization of the space sector, let's call it that, could result or might contribute to more and more let me see if I understand the question correctly. No, sorry, as far as I understand the question correctly, it's about how can we avoid that sort of the same driving issues that, well, cause us to transgress the planetary boundaries here on Earth, that this also sort of is actually the engine for the whole space industry, so that we sort of run into the same trouble again when we leave planet Earth.
Yeah, it is related. I would refer to my previous answer, and maybe I can add that I sometimes use the image of a phase transition. I'm assuming that we have lots of scientists here in our audience, and if you want to bring to induce a phase transition of maybe water and bring it from the liquid to the water vapor phase, you can heat it up, but you can also lower the surrounding pressure. So the phase transition, as we know from the phase diagram, is dependent on two variables, independent variables: pressure, surrounding pressure, and temperature. And how much more will a transition to a sustainable society depend on many, many, many different variables? It's not just two, it's not 10, it's probably dozens, if not hundreds of parameters. And if we only bring pressure on one and think, now let's do X, Y, Z, and miss that there are 90 others that we don't pay attention to, we will not succeed. Because then you basically you can also end up in a pressure cooker. If you heat up water to 120 degrees, but increase the pressure at the same time, you will not succeed with that phase transition. And that is, for me, an image or a metaphor for the phase transition we need to have towards sustainability. So we need a comprehensive view. And my hope is that we can now see in many regions, in many parts of society, that we might come to a point of a phase transition. We see Fridays for Future. We see in Europe the European Green Deal of the European Commission. We see asset managers like BlackRock urging the CEOs of large corporations to do more about climate change. So we see from many, many different angles institutions going into similar direction. And that is a promising sign. Historically, we know that large societal transformations are never monocausal. They have always had many different reasons. And that is also, and therefore we need, like in the illustration of the phase transition of water, you need to trigger both pressure and temperature. And once you do that, you can actually reach a phase transition quite soon. And my hope is that we're currently, and maybe the pandemics helps here, we're currently in a phase of an increased awareness. We cannot continue on this unsustainable path. And and therefore I hope once we resolve this issue, we will also address the kind of the space race for resources and come to a more sustainable approach where we have more cooperation and less competition on the natural resources. I hope that answers sort of the question.
Thank you so much, Christian. I'm back. I hope you hear me now. Yeah, I had
Loud and clear.
My internet went down just at the time, you know, as it always is. I'm not connected through my phone, but it seems to work fine. So thank you again. I was able to listen to your talk and to the discussion. I much appreciated your thoughts. We have now the next talk coming up by Xiao-Shan. Just to my introductory remarks, I will do during the first coffee break. Who wants to listen to it? Yeah, so I will make a wrap-up version so we keep the time schedule and don't have any interference because people might connect just for a certain talk. So thank you again, Christian, and
I'm glad you're back, Andreas, and thanks for setting this up. And I'm really sorry for you that you missed some parts. But that's life, you know. Life is what happens while we're making other plans, as John Lennon said.
Yeah,
we're all in a good, productive, and stimulating continuous day. Thank you.
Thank you, and you will be with us again at the panel at the end of the workshop. So who wants to discuss more with Christian, stay tuned and be back then. So now we hand over to Dr. Xiao-Shan. Welcome, and you already, you're familiar with the people, I guess, because you were there when I have been offline. So she is a research scientist at the Environmental Social Sciences Department at EAWAG in Switzerland, and guest assistant professor at Copernicus Institute of Sustainable Development, Utrecht. Although trained as a development economist, Xiao-Shan has worked across different social sciences disciplines with a primary focus on development and sustainability issues. In the past, she has run empirical fieldwork on sectors ranging from semiconductors and integrated circuits to solar photovoltaic energy integration, as well as water recycling and sanitation across different countries, including Taiwan, China, India, and South Africa. In 2020, she founded the Earth-Space Sustainability Research Initiative with the aim of using evidence-based social science research to inform forward-looking policy scenarios concerning space governance. And that's what her talk will be about Earth-Space sustainability, challenges in active space debris removal through discourse network analysis. Xiao-Shan, the floor is yours.
Thank you, Andreas. I will share my screen now. Please let me know if you cannot see the slides. Can you see the slides?
Looks perfect.
Thank you very much. Yes, so thank you for the introduction. And today, essentially, I would like to share with you a research agenda that I am currently pursuing, which I try to establish a framework of Earth-space sustainability. So basically, my research on Earth-space sustainability focuses on near-Earth environment, which includes from the Earth to the Earth orbit, such as to the geostationary orbit, but also the environment between the Earth and the Moon due to increasing activities in this area. So the essential question that we are asking is, can we actually establish a future sustainable and functioning Earth-space system? So on one hand, we are increasingly seeing how space-based infrastructures are offering new opportunities to actually accelerate sustainable development on Earth. And examples, these are very salient examples, not new to the community today. We are looking at the potential of Earth observations, internet satellite mega constellations, potentially bridging digital divide, but also navigation systems that actually transform environmental management. So we look at each of these as specific issue areas or cases to be studied in depth. On the other hand, we also see increasing governance challenges to actually manage the sustainability issues in these near-Earth environments. So issue areas include space debris or space traffic management, equal and fair allocation of radio frequency, the logistics issues between Earth-Moon environments, as well as activities on celestial bodies such as on the Moon. So by looking in depth into these different issue areas, it is with the hope that we can better understand the opportunities and challenges towards a sustainable functioning Earth space system into the future. So by reviewing the existing scientific literatures, but also policy reports, we identified 3 major challenges if we were to establish an Earth space sustainability in the future. First, there is a severe lack of social understanding on social and technological complexities. We simply do not know enough about the social and technological challenges or the strategies, business models, interests, value orientations of these different space users. Without better understanding these social and technological complexities, it is very difficult for us to anticipate the rapidly evolving innovations and to be able to foresight the future or longer-term development trajectories. A second major challenge is that we see more and more discussions basically labeling space as a new tragedy of the commons. But the question is how to systematically address space as a commons. We need to better understand what sort of common pool resources we are talking about and in what specific context. So if we are witnessing these major shifts in the space sector in the recent years, we could also foresee or anticipate the next era of space governance would be something quite different. And this is something that we call as the global institutional architectures for Earth space sustainability. Since we don't foresee any unifying global structures for space governance in the near future, it can be expected that there will be different institutional structures emerging across different levels in the world. And we need to better understand how well these institutional functions, these institutional architectures actually function and whether they can promise for a sustainable Earth space system. To do so, we need to first understand the development trajectories, which one would be more or less sustainable, which policies will be suitable to support the more sustainable trajectories, and what kind of specific institutional configurations are actors currently pushing for, and what would those be into the future. So with that brief introduction, I would like now to share with you an in-depth case study that I have been running together with 2 colleagues at EAWAG, Jonas Heiber and Bernhard Truffer, which we basically look into the development of the active debris removal challenge through a discourse network analysis method. So what is a discourse network analysis? Essentially, we map the discussed topics among core actors in the space sector over a long period of time. And we map these discussions drawing from a data set. And in this case, for this presentation, I'm sharing with you about 300 articles from newspaper and magazine sources. So essentially, we map the discussed topics among the core space actors in these public media. To derive this particular set of articles, we use a systematic search string protocols, and also we establish a systematic coding scheme, which will then help us to derive first concept networks. These concept networks basically show how different ideas, interests, or concerns or value orientations among different actors are linked to each other. With these concept networks, we can mirror some kind of actor networks, which actually demonstrate which actors share similar ideas, interests, concerns, or value orientations, even though they might not have explicit collaborations yet. So, for the networks, we basically also distinguish them into specific time periods. This is a quick run through. For the first period of time, it started back in 2007. It was when there was news about anti-satellite tests by the Chinese government, and we have the first collision of telco satellites. Whereas the second period of time was when the US National Research Council report published and actually warned the space community that we have reached a tipping point when it comes to the problem of space debris, and we need more R&D attention on active debris removal. The third period of time was when the first satellite Megaconstellations projects were announced by the big space commercial companies, which then started to gravitate certain interest across this public media again. Whereas in the last period of time was when these mega constellations projects actually came into real implementations, and we received news about actual launches of these satellites. So I would like to first share with you the first period of time in terms of concept networks. And as we can see, let me use the laser pointer. Yes. As we can see in the first period of time, we see a very clear but rather still simplistic structure in terms of concept networks. So the ADR, the active debris removal concept, was very new. And at that time, it was strongly connected or associated with the concerns of finances. So when the idea of actively sending robots and new machines into the orbit and actively removing certain debris from the orbit, the core concern of the space actors were mainly who were going to be responsible to actually pay for this huge cost. At the same time, discussions of ADR was closely associated with the need for a decentralized guidance or a decentralized governance mode across the world. Who should take the leadership? And this is also closely related to increasing need for international cooperation and data sharing or transparency. At the same time, we obviously also had the licensing issues. Who should take the leadership in monitoring licensing issues or rights? And this ADR concept was also very directly connected to the concerns for safety for spaceships. If we do not actively remove the existing debris in the orbit, it could cause safety issues to human carrying spaceships, for instance. For the third period of time, don't have to try to read this, but I would like to just show you the third period of time was when the commercial companies first introduced or announced that their mega constellations projects have been approved or will officially be implemented. We saw that in this period of time, there was definitely a shift in the kinds of discussions and concerns among the actors. The different topics became more dispersed and more diversified, and there was a reshuffling of which topics or concerns became most prominent. So it was almost like a response from these actors not knowing how to handle with this rather a shock of this sort of news. And let's see, in the last period of time, we basically see that these concerns became much more focused, clustered around here, and certain issues or concerns became more prominent. For instance, the idea of ADR, active debris removal, was closely associated with the concerns that existing guidelines for space debris management was only voluntarily based. At the same time, private actors expressed their concerns, saying that more regulations might actually limit commercial development. So we saw different competing interests and value orientations in this period of time. And obviously it is closely connected to the concerns for how to systematically address space as a common pool resources and the higher potentials for Kessler syndrome. On the other hand, some other bigger issues includes still the need for transparency, international cooperation, and data sharing, which is still closely connected to the needs for a more decentralized form of governance. Interestingly, we also see that in this period of time in blue was when we saw many more private projects, commercial projects, or initiatives popping up. So they are in blue. And obviously we have a mixture of ADR related initiatives, but also other commercial companies like OneWeb that participate in Megaconstellations projects, but we also have other private initiatives that focus on active debris removal. We would like to put these initiatives or private activities into the perspective as well. So the same concept networks, we can basically mirror into actor networks, which shows how different actors across these periods of time actually share similar ideas, concerns, or value orientations, although they might not have explicit or formal connections in this period of time. So in the first period of time following the anti-satellite test and the collisions, we saw that the concerns of NASA was very similar to ESA. This is of no surprise, but also to prominent actors such as the Secure World Foundation, the Japanese agency, and the US government. We also saw other international platforms that actually engage with this sort of discussions. And very quickly, again, we look at a third period of time when the Megaconstellations projects were first formally announced. And we saw that again, these actors and their convergence of or similarities in terms of concerns became much more dispersed and much more dynamic. And it was also this period of time that we saw ADR initiatives popping up. But I will now move into the last period of time, which we saw and observed a much clearer clustering among actors in terms of their similarity, similar ideas or value orientations. So we saw that ESA has definitely been in the center of the discussions, and they share very similar ideas with, for instance, clearly with ClearSpace 1, with NASA, and other prominent actors as well. And interestingly, we see that although Astroscale is a private company based in the US, focusing on space sustainability and quite explicitly on space debris management, share very similar ideas, ideologies, or value considerations with ESA, although they might not have formal collaborations at this point, but it indicates that they do share similarities and might project potentials for future collaborations. What is more obvious in this last period of time, we definitely saw a multiplication of actors in terms of numbers, but also in terms of the types of actors. We saw more participation from the developing countries, including the Brazilian government or the Iranian government, but also at the same time, we saw much more private or non-governmental activities highlighted in orange in this period of time. And again, we had a mixture of the companies they are promoting for mega constellations, but also companies which are more active in promoting space debris management or ADR initiatives. So overall, we could derive the most promising trends or the most important factors or criteria across each of these phases, from collision to the first scientific reports that warned the tipping point, to the game-changing time periods when private companies introduced the idea of mega constellation project, leading to real launches of these satellites forming big constellations. And we can focus on one of the most pressing issues across this period of time in terms of governance challenges. And we see that which of these governance challenges actually were repeatedly emphasized across this period of time, but have not come to clear conclusion. And this was obviously a struggle between a more centralized and decentralized governance systems at the global level, and the needs for international data sharing and transparency. So moving forward, what can we actually do with this analysis? What I have shared with you was one single case study on the challenge of actively removing debris from the orbit. And each of these case studies help us better understand the longer-term development trajectories so that we could project into the future and derive forward-looking policy scenarios, which at the same time incorporating fast-moving factors and strategies. And we are repeating the same study for different cases at the moment, for instance, in space security, in navigation, in Earth observation opportunities, but also the use of Earth observations for the Arctic governance. And each of these cases will again help us to project longer-term development trajectories, leading to different sets of policy scenarios. Following this, we can then derive an integrated overarching view of different airspace development trajectories. We can then more systematically assess the trade-offs between Earth and space sustainability and actually look into which policies could work. And finally, this will help us to derive the overall global institutional architectures that could actually promise a sustainable and functioning airspace system into the future. With that, I would like to end my presentation.
Thank you so much, Shan. Very insightful. I'm very curious now what you project into the future from you. You say you can project and what you would project. Is there any thought on that already?
Well, this is definitely still an ongoing research, and we are updating the data and analysis on a regular basis. But essentially what we do by better understanding the different value orientations or different interests and concerns among different actors, we can better understand how these actors actually respond over a longer period of time following different kinds of external shocks or different kinds of developments from their competitors or from their other actors in the same community. And with that, we can sort of foresight into the future how it would overall develop in the next 5 years or even in the next 10 years. But it could lead to different kind of trajectories, which means we will have different scenarios into the future and different policy responses to deal with this kind of different scenarios.
Thank you. André, are there already questions from the audience?
Yes, there are. We actually have 2 questions. We're gonna see how much time we have left to actually answer them, but I'm gonna read that. The first question was by Guillaume Delannoy. Yeah, again, recognizing that there are many commons between Earth resources and space resources. So this tragedy of the commons, that sounds plausible. And the question by Guillaume then was, one part of the solution might be found through those terrestrial matters that are addressed through the common goods economics developed by the UN Nobel Prize winner Jean Tirole. Have you investigated that path?
Well, thank you. I guess I have not specifically investigated this particular path, but it is definitely one of the major interests to look into how we can better address common pool resources in space. So I'm not sure whether I'm directly answering your question, but at the moment, what we find is that there has been quite a or sweeping generalization to say the outer space is a common pool resources, and it has led to tragedy of the commons. But we need to better understand in what context we refer to this, what sort of resource units we're talking about, and what are they being used for, and whether they are used in a just and equitable manner.
All right, and I'll just read the second question or other comment by Loïc Miro. So, despite of numerous climate summits, we're still emitting more and more fossil fuels, and so in spite of debris guidelines, we are launching more and more satellites. So the worry is basically in one sentence here, isn't current governance too weak? So talking about space debris.
Yes, definitely. I think most of the speakers today and some of the participants will share this similar idea that the governance, the former governance when it comes to space debris management is definitely quite weak at the moment. And it is an ongoing discussion whether a voluntarily based structure could be really sustainable in the future, or should we actually impose liability or sanctions in a stricter form? But because the sector has evolved so much and has been increasingly privatized, it is no longer the same as once we knew about the old space. So taking into account this different interests of different actors and the private actors, and what these private actors how they use space for actually different earthbound services, these all have to come into questions. So the governance or the institutional architectures that we derived or we strive to push for should actually take into considerations these aspects. They should be able to be effective, but at the same time taking into account fair and sustainable use of space for the right reasons.
Thanks a lot. There are two other questions, but I think we're eating into the break time or into the time where Andreas briefly wanted to give an overview of planetary sustainability, which we missed in the beginning because of technical issues. But yeah, just there were two further questions by Hubert Meisinger and Gurpreet Singh, but maybe we'll have to take them either later or maybe you can contact directly Shan. Andreas, what do you propose?
Yeah, I think we should answer them quickly and then have a break, because then it's now a bit stuffed. So I suggested I will move my intro to the lunch break, also after the
all right, yeah.
Because then we all need a short break, and then it's just a hurry.
All right, that's fine with me. So Hubert Meisinger just pointed out that ESA gained strength after Jan Werner became its director. So the question is, what role do individual persons and their interests play in the scene? So when we talk about governance and space debris.
Yes, yes. So we definitely take into considerations these individual actors that have strong leadership, especially in space agencies. So when we are analyzing this data, we basically would code and assign statements or the interest or value orientations or concerns expressed by as a director as representing ESA itself. So although you don't see the name of Jan Warner in the actor networks, his considerations have been taken into account representing ESA. So thank you for the question.
Thanks a lot. And the question by Gurpreet Singh. So question to Xiao-Shan. In terms of more developing countries participate now in space development, do you consider equitable access to space as a part of the space sustainability framework? Or actually, that's a question to you, and of course also to me and Andreas, obviously. Yeah.
Yeah. Yes, yes. So this is definitely a very good question and a very important one. I believe all policymakers are still struggling with this dilemma because opening the space sector is providing so many opportunities. Again, we have to look into what kind of opportunities these are, but developing countries having having the status of less privileged in terms of technological development might not have the same kind of access to space, especially if they do not have the capacity to develop their own database of what's happening in the Earth's orbit, for instance. Then that actually prohibits them to be more active and know what to do next. And so opening the space for all is definitely important so that the space sector will not actually widen the developmental gap that the world has been experiencing so far. But this could lead to many consequences, especially in terms of the sustainability status in Earth's orbit, because then if we loosen the conditions to participate in space, that means more activities, more private innovations, and then leading to more accumulations of environmental issues in Earth's orbit. So this is, I don't think this is something that I know enough to answer today, but this is a common challenge that we all should look into.
Yeah, I think you expressed the dilemma quite well. There is, and I think we need to find new ways of benefit sharing somehow and more cooperative stance, which is actually ideally in the idea of the Outer Space Treaty and maybe the Moon Agreement. Yeah, I think this is a big question also that we can maybe discuss also at the end of the day and after we are listening to all the talks. Thank you, Shan, very much for this insightful presentation. And we'll have a short coffee break now and come back to you at 10:40 for the next talk by Thomas Schildknecht.
Thank you.
Thank you. Oops. Yeah, and welcome back. Thomas, are you here?
Yes, I'm here.
Great. I guess your camera is turned off and it's not my connection. No, no, it's all fine. So, great to see you. I will shortly present you and then you can start with your talk. So Professor Dr. Thomas Schildknecht is a leading expert on space debris, space safety and space sustainability. Under his leadership for more than 25 years, his research group has acquired a world-class expertise in the observation and the characterization of space debris. He's the director of the Swiss Optical Ground Station and Geodynamics Observatory Zimmerwald and the vice director of the Astronomical Institute of the University of Bern, Switzerland. At both national and global level, he has served and continues to serve in numerous technical and policy-making committees. He is a member of the Swiss delegation at Lund Cottbus and substantially contributed to the work of its working group on long-term sustainability of outer space activities. At ESA, he is currently the chair of the ESA Space Safety Advisory Group, advising the ESA director responsible for the space safety program. Thomas, you will talk about environmental challenges in the plural, because there are actually two talks we will have now combined into one piece of impact. Space debris, mega constellation, and the preservation of our night sky is your topic. The floor is yours. Thank you so much for your willingness to present.
Thank you, Andreas, and thank you for giving me the opportunity to tell you a little bit about, let's say, the more technical aspects of the topic we are dealing with today. I would like to share my screen, see if we are able to do that.
We see it fine.
You see my screen?
Yes.
Okay. So, as you mentioned, the topic is environmental challenges, and I will talk first about space debris in general and give you an introduction what we are talking about. So let's have a look at the historical evolution. This is the picture we had 1960 of our near Earth space environment. On the left-hand side, you see always the Earth from a distance of about 5 Earth radii, and on the right-hand side, you see a close-up of the near Earth space, what we call the low Earth orbit space. 1960, a few objects in Leo, nothing else. So 5 years later, we have a few objects higher up, more objects. 1970, we see already a clear indication of a ring here, a ring which is at roughly 36,000 kilometers altitude, which we call the geostationary ring. 75, 80, 85, 90, 95, 2000. And you see in both regions, in the lowest region here, where we have this beehive of artificial objects, as well as in high altitude regions where we have the ring, the geostationary ring, and many, many orbits in between Leo and this high altitude regime. So this was the situation in the year 2000, steadily increasing. 2005, 2010, steadily increasing. So what do we know right now? What you see here is the current catalog of objects we know, which is for larger than about 10 centimeters, roughly 35,000 objects. We know most of them by name, we know their orbits, but we have a lot of objects up there, about 60,000, larger than 5 centimeters, which we don't know by name. And we have a huge amount of small size objects, about 1 million, of the order of 1 centimeter and larger. And why are we talking about 1 centimeter? Simply because 1 centimeter up there in space is very dangerous for any other object, because when it collides with another object, it will release the energy of a hand grenade. So this is the very reason why we look at these sizes. So once again, larger than 1 meter. This is the picture currently, larger than 10 centimeters, larger than 1 centimeter. And if we go even further, larger than 1 millimeter, we are talking about billions of small size objects. So what is the risk? And I'm going to show you the risk for just one particular object. This is a historical image here with the space shuttle docked Endeavour here. What you see here is the robotic arm inspecting the lower side of the space shuttle. it took 2 days in the last missions to make sure that you can safely return with a space shuttle, to make sure that there were no impacts on the heat tiles from space debris. If we look at the station in general, we see that it is really peppered with impacts. A few examples here. A solar cell knocked out a hole in the outer protection layer. The hole here on the top left, you see, this is a part of the thermal insulation of the space station, 5 centimeter hole. This impactor here barely was almost penetrating the back wall of the space station. So there's many indications that space debris, and in particular the small size space debris, pose a substantial risk to operations in space in general, at least in the near Earth environment. Another example here, this is Sentinel-1A, one of these Earth observation satellites of the European Union, which suffered an impact on August 23 and 2016. Without that picture here from an onboard camera, we would even not have known probably that this was an impact from a space debris. There was only a small power loss, attitude was disturbed, and the orbit was changed. And with all of that, we could assess that the impactor was of the order of millimeter. So the space surveillance network later on found 5 debris pieces, probably parts which peeled off from the impact here in the vicinity of this object. So collisions with space debris do happen, and this is something which came to, let's say, the attention of the wider public in February 2009, when 2 large objects, decommissioned Russian satellite and an active Iridium satellite collided. And what you see here is the evolution of the fragments over only a few months here. You see these fragments spread over a large area or shell in space within a few years. What it means, we have from this single collision, apart from the fact that we lost an operational satellite, we have thousands and thousands of objects now in space which are orbiting or have been polluting an entire shell around the Earth. And we are constantly required to avoid collisions with one of these objects by maneuvering our active spacecraft. That was really triggering the wider public and politicians. On the other hand, it was an event which was predicted by our models. We were not surprised, but it had to happen in order to really trigger a wider awareness. Another type of events which happens regularly are what we call breakups. Many of the upper stages, or all of the upper stages by the end of their mission have some residual fuel, and if you don't vent that fuel, it can explode even decades after the end of the mission. The same for stored energy in dead satellites, for example, batteries, any type of energy stored in a satellite. This is just one example. I don't think you see it in the stream, but what you see here is a series of observations we made with hundreds here or dozens here of debris pieces from a breakup from an upper stage. It was done at our observatory here in Switzerland. Another example here, breakup from an upper stage, which produced hundreds of fragments. And all of these fragments contribute to what we call the space debris population. So, why should we care? That really depends on, what is your interest in space. If you're a satellite owner or operator, of course, you care about the safety of flight. because you have a precious asset up there which you want to use. You want to prevent collisions. So you want to have a traffic management, you want to avoid collisions by doing maneuvers. And if you have a problem with your satellite, you want to know the cause. You want to know why is my satellite, why became it dead, for example. Be aware that if we are talking about all these things here, that space today is still, it was originally mainly a military area or theater, and it is still dominated by military or defense interests. So when talking about traffic management, talking about collision avoidance, we need to take into account that we need the information about where other objects are, and this information is even today not freely available for all the objects because of, as I mentioned, the military aspect of all of this. So as a spacecraft designer, you want to know more about risk analysis. Can I do shielding like we did on the space station? Shielding of what? Can I shield larger objects, smaller objects? If you're a mission analyst or you're conducting launch campaigns, you want to optimize your trajectory. You do what we call conjunction analysis. You look up the catalog of orbits and see if you have a safe path through all that debris. Governments, space agencies, scientists have completely different, stakes in all of this. So governments, as a government, we would like to protect vital space services. We also call them critical infrastructure. And some of them were mentioned this morning. Just to name one, navigation constellations. We all rely on being able to use our smartphone or our navigation system in cars. It's even more so when you think of autonomous cars, which rely on all of these space infrastructures to safely drive here on Earth. There's many other examples, Earth observation and so on and so forth, communication. And then as a scientist, I care about the long-term sustainable use of space, and I look at how is this environment evolving over time. Many of these things we are talking here are very similar to what we face in the global warming or climate scene. Many of the mechanisms, many of the issues we have in discussing these issues at the national and international level are very, very similar to the ones we face when in the global warming or climate discussion. So we do research. So we have a series of open questions. So first of all, how much is out there? How many? What's the sizes? What the orbit regions? What is the nature of the object? In many cases, we don't even know the natures. What are the sources, the sinks? It's very similar to, again, the climate modeling or observations we need. What is the physics, creation of space debris, evolution of the orbits, long-term evolution? So we need models. And finally, of course, what do we do really in my institute is we search for debris, what we call surveillance. We determine their orbits and we characterize the debris. I would really insist that this is physical characterization because the term is very often used in the defense community. It is slightly different. Characterizing would then mean to assess the functionality, the intent, and so on and so forth. We are talking about physics here. So we have our own observatory in Bern, near Bern, not really in the town, but near Bern, which we use with a series of telescopes, some of them fully dedicated to this topic. to space debris. This is just, yeah, some of these telescopes. We have a 1 meter telescope, we have an 80 centimeter, we have wide field telescopes. They're all in Zimmerwald at the Swiss Optical Ground Station. And we use, on behalf of ESA, for example, a 1 meter telescope in Tenerife to do deep surveys for small size debris pieces. We have our own robotic telescopes in, for example, here in Sutherland, South Africa. This is a collaboration with the German space agency, the EAWAG. We have one in Australia, all used to better assess the current status of the space debris population in near-Earth environment. And that is really the basis for coming up with models and looking at the evolution or possible evolution of that environment. We also use lasers. Just wanted to mention that. We do high accuracy determination of orbits using distance measurements by using lasers, as you see here. This is also important because if you want to avoid a collision, you really need to know the trajectory of the let's say, other objects very, very precisely. Otherwise, you do a maneuver which is not necessary, or you maneuver in the wrong direction. You want to avoid the other object by turning right, and yeah, and the object is in fact there where you want to avoid it. So you need very precise information. All this is not trivial, and all this again is, as I mentioned, to be seen in this overall theater of many, many different actors with commercial interests, military interests, and so on and so forth. So this is the reason why, for example, high precision orbits are not just available like this. So what do we know? To give you one example, on the left-hand side here, this is the population as of December 3, 2019, from the publicly available information. And this is the situation when we add a series of fragments from 3 recent fragmentation events which happened, but the fragments were only, cataloged by academia. This is actually our own catalog, which we maintain together with Russian colleagues and other colleagues. So this should also give you or tell you simply what you hear about the status of this environment. This is by far not the full truth for many different reasons. So yes, I mean, this animation here is showing you again just these 3 events. They produced thousands of objects which are still, orbiting in these 3 particular planes here, and pose a risk to any object which is crossing any of these regions here. So space debris is a serious issue, and we need to make sure that we have no unlimited proliferation of this type of objects. So let's have a look at what happened in terms of traffic. So what you see here is the number of objects which we know, I would say by name, and when I say by name, we know their orbits. Different classes, you have in red, you have the payloads, so the satellites. Then in green, you have the payload fragmentation debris. So these are debris which were produced either by collisions or by explosions. And you have the rocket fragmentation debris here in yellow, rocket bodies. And you have unidentified, let's say, objects here. What you see here is the steep increase in 2009, this is the Iridium-Cosmos collision, and the, I would say, exponential increase on the right-hand side here is due to several, or still ongoing, regular breakup events and the increase in traffic. This, be aware, this is the number of objects. It's not the mass. And this has a reason. If we look at the payload launched over the years, this is the number of, we would call them satellites. First of all, for a long period, we had about 100 payloads launched every year until about 2010, and then we had an increase. We had even a decrease before. This was due to the military or defense part declining here, and about 2010, we had more and more launches of smaller satellites, and in particular commercial satellites. In 2020, you see more than 1,000 commercial satellites launched. You all know this is because of what we call megaconstellations, and launches with more than 100 or 110 small size objects. This graph here gives you the size of the objects. So many of these objects here launched recently, as I mentioned, private ones, are of the order of 100 or a few hundred kilos only, while in former times we used to launch satellites which were at least of the order of a ton or several tons in mass. And we have only a few, we have still large objects launched here, but these are a minor part. And we have a lot of very small satellites, CubeSats, 10 by 10 by 10 centimeters, launched by academic institutions, but also by commercial ones nowadays. So let's have a look at what we call the conjunction statistics. And this is an example from ESA. This is the number of near encounters ESA had to treat over the years. So to have a closer look at, and then eventually to do an avoidance maneuver. And the interesting thing here is, of course, they're increasing. This is only percentage here. The number of cases is increasing. But the interesting thing is that for a long time, we had mostly conjunctions with payload related fragments. So collision fragments from Iridium-Cosmos or breakup fragments. And then, of course, also quite some fragments which were rocket-related, explosion fragments. But recently, you know, these conjunction events are dominated by satellites. Again, this is an indication for the upcoming and deployed, right now deployed constellation of satellites, thousands and thousands of satellites. Let's have a look at the future. I mean, this is an older chart. We did simulations all the time since more than 25 years to look at how the future will evolve, including these collisions I have been mentioning, which will take place. That's no doubt. The question is only when is the next going to happen? So all these predictions tell you that the number of objects here, this is the number of objects, will grow in low Earth orbit exponentially. This is what we call the Kessler syndrome, predicted by Kessler in the 70s, by the way, an exponential increase. It's a bit less critical in MEO and GEO, but still. Let's have, and this is without simulations, without constellations. So what can we do in order to protect the space environment? And quite a long time ago, it was clear that we need to mitigate the proliferation of space debris by preventing explosions, by limiting the orbital lifetime, which means make sure that your object is not staying where you left it. I mean, nobody would, let's say, leave a broken car on a highway. just leave it where, you know, it broke down. No, you take it away and you recycle it or whatever you do it, but you cannot leave it just in the middle of the road. But that's what's happening today. So do post-mission disposal, deorbit the objects. We need control deorbit in case of risk objects. Of course, we don't want to, these objects falling on our heads. So we need to do that in a controlled way. For higher orbits, we need graveyard orbits because it's at these altitudes, it is really too costly to bring them back into the Earth's atmosphere. So do collision avoidance the best you can, but be aware most of the objects are not maneuverable because they're debris objects. And we can think about remediation, and the previous talk was focusing on that, cleanup, active debris removal. I mean, this is technically, economically, and politically, last but not least, all the legal issues extremely challenging. So again, let's have a look what these measures could help us. And here you see again the number. This time it's the number of catastrophic collisions over the next 200 years. And we are talking about dozens and dozens of collisions. If we do nothing, just business as usual, you see this black line here, exponential growth. If we do post-mission disposal, so take out the objects from the orbit for 30%, 60%, 90%. So we need to do 90% post-mission disposal to moderate that exponential growth, perhaps even reduce the growth a little bit. Again, no constellations. This is just a movie showing this behavior or this evolution. It's you see here the years, one of the simulations. Each of these events here is a collision event between mostly space debris objects. Only a few of them are active objects. And this might be one reason why, you know, as an operator, you are concerned about your active spacecraft. You're not concerned about what's happening with the environment. All in all, at least not for the next few years to come, because your stakeholders, they want to see their shares and they're not interested in the environment in 100 years or 200 years from now. That's part of the problem. So let's have a look at megaconstellations. Megaconstellations are constellations of not just dozens, but hundreds or thousands of objects, which are currently deployed. And you know, some of them, of course, SpaceX, which has until now deployed about 1,400 of their first constellation, which will be roughly 1,500 in low Earth orbit, 550 kilometers altitude. There's a second generation, where we are talking about 7,500 objects, even a bit further down. There's OneWeb, which has deployed almost 200 objects. Last launch just a few days ago. Their constellation will consist of about 650 satellites in 1,200 kilometers altitude. And there's Creeper. We don't know yet when the first launches will happen. Again, 3,000. And there's many more constellations on the drawing boards. So if we take them into account once again with our simulations, things look pretty much different. So the blue curve here is the evolution of the environment without new constellations, but 90% post-mission disposals, no explosions anymore or breakups. And we had a few last years. Even this year. And this is with the constellation assuming 90% post-mission disposal. So you see, even with 90% post-mission disposal, we'll have a time frame where we have really a lot of objects out there because of these new constellations. And keep in mind, the current post-mission disposal compliance is extremely low. We are not talking about 90% in Leo. We are talking more like about 20%. So this is another aspect to take into account. So what about guidelines? What about, international rules? And you may know we have only treaties, binding treaties from the 60s, which are very general and very, very helpful, by the way. And then we have a series of non-binding guidelines. 2005, the first set of mitigation guidelines from the IADC. This is an interagency coordination committees between space agencies. And 2007, based on this set of guidelines, the UN Space Debris Mitigation Guidelines, and we had a draft International Code of Conduct from the EU. This one was not further pursued. And then after a long, very long, really long period, we came up, after about 10 years of work in the UN, we came up with the PLASUS21 guidelines on the long-term sustainability of outer space. These are all non-binding guidelines, and currently the international, negotiations or multinational discussions are very difficult. One, just to give you one example, we needed more than 2 years after the COPUS decided to establish a follow-on working group. We needed more than 2 years to come up with a bureau or a chair of that working group. Tells a lot. Okay, so yes, we can clean up, and that is going to be the topic of the next talk. I don't want to go into details here, but I would like to come to a different topic now. Satellite constellations and society. So many of you have been seeing these strings of pearls, 30 satellites or 60 satellites in a row crossing over the sky. And they're fascinating, but do we want to see these string of pearls all the time, everywhere on Earth? Let's say if you go into the outback of Australia, if you go to the Antarctic, if you go to Africa, in a dark area, do you want to see hundreds, more than 100 satellites moving over the sky, visible with your naked eyes? Probably not. So we have to think about the question if the pristine night sky is a human heritage. And if we think it is, how can we ensure protection of that heritage? Dark and quiet skies for science and societies, the society, let's say. On the left-hand side, you see the troubles we have as astronomers. This is a single exposure from an 8-meter telescope. Only a minute or so, and you see dozens of streaks here. Each and every probably large field exposure in future will have one or more satellite streaks on. There is more than that. The small size objects, they result in a diffuse background, diffuse sky background from small size artificial objects. And this is often forgotten. All these objects here, each and every of these satellites is emitting radio waves. So we have a huge amount of radio noise from these satellites. So radio astronomy is strongly concerned by this evolution. So light pollution, and no, not by artificial light from ground, but artificial light from space or artificial objects from space, and the radio noise may cut us from accessing the sky. It may cut us from accessing knowledge about our universe. So really think about this. If we cannot anymore do radio astronomy, we lose a very important part of our sky to get more information about our universe in general. And here, there's currently zero, really zero regulation at all. The Outer Space Treaty, I mean, this fundamental treaty from the 60s, only guarantees freedom for exploration and peaceful use of space for all mankind, free access to space, and the freedom of scientific investigation in outer space, So nothing else. So we're not talking about protecting that environment. We are not talking about protecting the access from ground to the sky. That is not regulated, or there is nothing about this in the Outer Space Treaty. And there's nothing even in the current guidelines at, for example, UN level or national regulations. So what are the technical means to protect, preserve the night sky? And there are, you can darken the satellite or prevent glints. I mean, this is an example from SpaceX Starlink satellites. They darken their satellites so they're less visible. They're added shades so that the sunlight cannot be directly reflected by the satellite under certain circumstances. So this is all to protect the pristine night sky, so they're not anymore visible to the naked eye. And the third protection measure is by orienting the satellites in a way that, at least when they're still on their way to the final orbit, that they're not producing glints or not visible to the naked eye. Once they're in their operational attitude, they're not visible to the naked eye anymore. But that doesn't help astronomers, because they're very bright objects for astronomers all the time. So the IAU, this is the International Astronomical Union, came up with their own studies, and of course, finally with a set of recommendations to the UN Code Plus, which were delivered or presented this week at Code Plus. Code Plus is going on right now. So the technical and scientific and technical subcommittee. So in a nutshell, the recommendations are that we need to preserve the pristine starry night sky, that we would like to establish dark sky oases, so places on Earth where we really protect the dark sky, not just by protecting it through limiting the ground-based illumination, for example, but also by limiting the pollution which is already up there in space. Limit the optical and radio brightness of satellites. Take into account these issues in the licensing process. Currently, depending on the national licensing processes, we are taking into account the space debris topic in the licensing, but we're not taking anything into account concerning the protection of the dark and bright skies. No high altitude constellations has to do with the fact that the higher up, the better you see them all over the entire night. We need to get precise orbit data so that, critical observations from Earth, from ground, can be time tagged to avoid, let's say, being spoiled by a crossing space object, and many, many more. So what do we need? Just in a nutshell, to wrap up, we really need to ensure the long-term sustainable use of outer space. We need to ensure protection of the dark and quiet skies for science and society, or the other way around, for the society, all of us, and in particular science as well. And we need stringent international rules. I don't want to, to talk if they have to be binding or not, and the mechanisms we need, but we need international rules together with the bottom-up mechanism. I mean, we have a lot of bottom-up initiatives that were mentioned this morning, coming up with ideas of rules of the road, rules of behavior, norms of behaviors, and so on and so forth, driven by the technical aspects, which is absolutely important, but we need the multilateral international discussion and finally international rules. Again, I may compare it with the climate issue. It's very, very similar to that. And we need mechanisms to ensure the enforcement. I don't mean enforcement by just penalties. They can have a multitude of mechanisms to enforce these rules. And of course, we would all prefer, something else than just penalties. But as I mentioned, there are mechanisms, and there are mechanisms which work right now. So, take home, I think it is really important that our societies, and not private companies, our societies need to decide on trade-offs between the benefits of what we do in space, and in particular mega constellations, and on one hand, and there's a lot of benefits. I have not had time to address these, but there's a lot, of course. And protecting the space environment, space debris, on the long term, and the dark and quiet skies as resources shared by all mankind. And with that, I would like to thank you for your time.
We thank you, Thomas, for this, addressing these two crucial challenges. Maybe challenges is already an euphemism. It should be called problems we have, because I feel like we already have them, so if I understood it right. Yeah. Now we are on a tight schedule, and my question would be: are you available to stay during the next two short talks and to have a shared common Q&A at the end of the morning session, or do you need to?
It would be fine with me to have the Q&A session at the end of the morning session. I will be able to stay at least partially.
Okay. Good, because I don't know if the other speakers have the time to stay longer. Maybe just one question that came to my mind. Is it that would it help to define something like for the planet, we have the scientific concept of the planetary boundaries as a kind of emergency alert when something goes wrong, and the 2 or 3 are already triggered, as we saw. Would it make sense to have sorts of an orbital boundaries concept, or would it be too late anyways already? Is it because it's too full already? What do you think? Something like that?
No, I think this is a very, thank you for the question. This is a very interesting idea, and it's already, I think there's work going on. I mean, we have, for example, work going on which is concerned with sustainability indices, for example. So a measure if, either individual missions, but more so a region in space is still sustainable. Is there still capacity in that region, or did we, already put too much up there? And I think this is very important to come up with these indices. They should be simple, really simple. One number. I mean, you have, we all know these things on consumables, it's red, blue, yellow, green. Green is good, a good guy. Things like that we should come up in space, and it's very important. The problem is, like with these environment indices on Earth, what are the limits? We have to come up, and this was my last statement, we have to come up, what would we like to sustain? Which risk do we want to take? Where, what is the limit? Do we accept a certain pollution? And what we do here on Earth, we have limits for all these pollution indices, and we'll have to come up with that. And this discussion is ongoing, is very important, but we are not yet there. We're still a long way to be there, but I think very important.
Thank you. Yeah, so we will go on with discussions after the next talk and the final talk from the morning. I thank you again, Thomas, for your contribution. I welcome now Luc Piguet. Bienvenue. He is the CEO and co-founder of ClearSpace, a groundbreaking initiative based in Lausanne to clear up space debris, so the problem we just heard about. In November 2020, ClearSpace signed a service contract with the European Space Agency worth 86.2 million euros to remove orbital debris. This mission, named ClearSpace 1, will see the first debris removed by 2025. Luc studied at EPFL with a degree in electrical engineering and an executive program of Stanford GSB. So thank you again, Luc, for taking the time to be with us today, and the floor is yours.
Thank you. Okay, so what I will try to bring through today is the perspective of in-orbit servicing. Right? How does a company that tries to develop services to actually clean up orbits look at the situation, not the problem? And I hope I'm not going to overlap a lot on what has been done before, but I will bring a more commercial perspective and look into the problem and seeing how can we build a commercial case to actually make a sustainable operation in space a viable option. So when we look at space, when we got started, what really pushed us to get started with a company after developing for several years technologies to capture objects in orbit with an EPFL in Lausanne is those figures. Those are taken from a study made by Darren McBride in a group of international experts in the field, looking at the 15 most dangerous objects in orbit today. So what it gives here is a number of non-functional complete objects in orbit today, which are complete satellites that are uncontrollable or not working anymore, or rocket bodies. So today we're about a little more than 5,000 complete objects in space, which are essentially failed satellites or used rocket bodies. And over the last 20 years, every single year, we added 74 new objects to this list. In comparison, taking into account the number of satellites Starlink is operating today, we have about 3,400 live satellites in orbit. And that gives a little the idea of what the ratio is between non-functioning or derelict objects we placed in space and that are still in space, and the number of active ones we have today. So essentially, when we look at it, it's very much like, if you want it, it's very much like the space infrastructure is a little like motorway infrastructure that has been running for 60 years without tow truck. And if we would have the motorway infrastructure without tow trucks, then we would have failed cars everywhere along the roads. There would be debris of collisions and problems that occurred during the long period those objects or those cars were on the road. And obviously it's an operation that would not be on long-term sustainable. The other dimension when we look at the space industry and the environment of space is that there's a coexistence of a lot of different interests. All those lines that we saw on the previous chart, which is just a close view of the orbits traced out of space track, all those lines are different operators from different countries and different military interests and different governmental interests. And here you can see the trace of the US orbits and the Russia orbits and the Chinese orbits and the French orbits. And you can see that they all actually coexist in exactly the same environment. So it's really a global problem that cannot just be addressed in one space, or not only be addressed only in one segment of activity, whether military or civil. This is a problem that has to be addressed as a whole. The other dimension that became really clear for us is that prevention is much cheaper than recovery, right? On Earth, when you have a major catastrophe, it's an estimated average that $1 invested in prevention saves about $15 to $17 in recovery. In space, this is even worse, because when a collision happens, the number of debris that is generated is massive, and all of the small debris that are generated remain life-threatening for missions and astronauts, and can remain there for a very long time. So what you see on the left is a trace of one satellite. For example, it could be the Cosmos satellite that was failed. And on the right, what you see is the traces of the debris field generated by the collision between Cosmos and Iridium, as it looks like today. And what you can see is that you've got those debris everywhere, right? So if we would need to clean up or remove the Cosmos satellite today the cost of this mission would be prohibitive, which means that it is not really a solution to wait until the disaster happened and try to clean up after. You have to do something before. There's another dimension when we look at the space industry, is how does the future look like, right? And everybody has seen the number of Starlink satellite launched over time. And maybe some of you have already seen this animation that was made by AGI, where all they did is to animate all the constellations that are going to be launched in the coming years, right? From 2017, not taking the past satellites, that's just a new one from 2017, based on their FCC application, all the ones that requested a license to launch. And you can see year by year how more and more satellites are launched, 2017, 2018. And what they try to illustrate here is the fundamental transformation the space industry is going through. When we started the project and we spun off ClearSpace from EPFL, the reason why we did that is because we saw what happened with OneWeb. We saw that OneWeb got 1.7 billion in financing from SoftBank to launch 2,000 satellites. We looked at it and we thought, oh, this is transformational. This is not a single event. This is a trend. What happens here is going to accelerate in the coming years. And the reason why we believe that is because for a new transformation to happen in a specific industry, it is generally driven by technology readiness levels and by infrastructure. And what happens in the space industry today is that launching a satellite in 2021 costs a fraction of the cost of launching a satellite in 2010 or in 20. And essentially, the cost to launch a satellite dropped from 50 to 100,000 per kilogram to about 2,000 to 5,000 per kilogram. And it's going to go even further down as more launcher develop technologies and capacity to go in orbit at a cost-effective way. The other thing that happened is that a few years ago, if you wanted to take an example of a multispectral satellite, you want to do multispectral images of the ground, you wanted to produce a satellite that does good quality images, multispectral quality images from the ground, you needed to build a satellite of the size of a Mini Cooper. Today, you can do that in a microwave oven, which means that you can send more capacity, more capabilities into orbit in a smaller package and in less kilograms, right? And this transformation is fundamental. It opens up a huge amount of possibilities for the future of the space industry. And this is what drives this change, right? And this is what SpaceX is doing right now, OneWeb is doing right now, and there's going to be many more after that. So what you can see here is how dramatic this evolution looks like over years. I'm just going to, this is a pretty long animation, so I'm just going to jump a little further, but you can see that typically what we will have in orbit tomorrow, even though maybe not all of those constellations are going to launch, what we will have in orbit tomorrow is going to be fundamentally different from what we had in the past, which means we have to change the way we operate. The next question is then, should we stop this, right? Should we say, okay, no, that's it. Let's not launch anything anymore, right? Should we stop this? And our answer is, in our perspective, we will be, I just lost the presentation. Give me a minute. I have to restart it. So we will be in a situation. There we go. Can you see my screen?
Yes, we can.
Oh yes. Okay. So in today, we're already completely dependent on those infrastructure, right? If, for example, we would lose GPS, we would lose not just the fact that you can navigate to your work or to visit somebody with your car and find your way to go to a shop or to the dentist. We would lose much more than that because our complete supply chain depends on GPS. The service synchronizations on internet depend on GPS. So there's a lot of consequences in losing services. If we lose specific services that are done in orbit are necessary for our life of our mode of life of today. And the more we go, the more we're going to be dependent on space infrastructure. And they make a lot of things possible that were just not impossible a few years ago. And as we move along, we will become more dependent on them. Another dimension about space internet, and typically the case of the Starlink constellation, it is completely understood that there's an impact on the space environment and the visibility of space, and there's problems to be solved with astronomers. The other side of the coin, and the other side of the coin is that if you want to connect the 300 billion of the human population to infrastructures like internet, the question could be, do we need to do that? But if you want to bring developing countries into developed mode, you will need to get them participating in our economy. If you want to do that, you can either lay millions and millions of fibers of fiber cables on the ground, or you can set up a space infrastructure for, like, say, 6 billion, right? So we made the calculation at the beginning and came to the conclusion that if you take, for example, just Switzerland, Swisscom today, to do the 4G network, needs about 8,000 base station transceivers, so 8,000 antennas. Every single antenna is about 150,000 Swiss francs of investment. So you get to close to 2 billion or 3 billion of investment just to cover Switzerland. A constellation like Starlink or a constellation like OneWeb is a total investment of 6 billion for a global coverage. So the question is, what should be done, right? The reason why we think this is not going to stop is because of that. We think this is not going to stop. This is going to evolve, to increase, and to accelerate. Now the question is, how do we operate something like this? How do we make sure that the future makes sense for everything we're going to do? We can say, okay, we should stop that kind of services. But the problem is the need is going to be there, and the way market works makes that they're going to happen. And I think we have to be aware of that and prepare for that. So one of the elements, there's a few elements that have to be in place to be able to have a sustainable safety, right? Space safety and sustainability in orbit. And those elements that are necessary is obviously a good space situational awareness. We have to have a very clear understanding of what is where and how. We need, obviously, collision avoidance and debris prevention. We should make sure we avoid collisions and don't produce more debris. But what we also need is servicing and active debris removal. And I think the presentation of Thomas before made it very clear. We cannot operate the space infrastructure in the coming year as we have been operating over the past years. So our perspective, when we looked at the problem, we thought, okay, how do we actually do that, right? How do you capture an object in orbit and remove it? So I'll show you a short video that you can find on YouTube.
Pierre went ahead and moved the capture bar to a horizontal and started to make his attempt to attach it.
Where NASA
and this is a view from the elbow camera, and I believe this is the very first attempt on the first day. And as Dan mentioned, it was a very dynamic situation, and it was something that I'm not sure we could really train for very well, particularly with hindsight. It's a very dynamic situation, and trying to put all those elements together in 1G to try to simulate 0G is very difficult, and we found that out. We also found out with that first attempt that the spacecraft was not quite as stable as we had anticipated. And the first time I touched it, it started coning off a little bit. This is another attempt on the first day. And you see in position, getting ready to put the bar on. And this time the satellite's in a little bit of a coning motion. So we were having to, I was having to con Bruce in and have him move me around quite a bit to get me in position. Had no luck with this attempt. See some motion of the arm as I try to put the bar on. And then I think what you're going to see is the last try on the second day. The first try on the second day was probably as good as we could have done it. And we actually got the bar up and got it up against the pads and actually about half the rotation of the spacecraft, but couldn't get the latches to fire. At this point, we've got the satellite down to basically no rotation. And I tried to put the bar on using the manual fire triggers, and I just couldn't hold the bar up quite tight enough to the ring to get the manual latches to fire, or to get them to grab. And after I touched it this time, you can see the spacecraft started kind of tumbling in a little different manner, and we kind of put it in a flat spin. So now it's rotating about an axis 90 degrees from its normal spin axis. And there's a shot out the aft flight deck window of what it looked like to Dan and those guys.
You can imagine at this point, we were all scratching our heads and pretty disappointed and starting to think about what was next. While on the MCC, they had the same reaction.
So what you can see here is just the reason why I share that with you is mostly to show you that it's not easy to capture an object in orbit. And there's several reasons for that. The first one is because there's no gravity, but it's microgravity. Second one is there's no friction. So any contact with the object generates spin and rotations that make it really difficult to do further operations. And in this specific mission, finally, if I jump a little further, they placed the 3 astronauts on the bridge that captured it with the hands. So it is quite a challenging problem, and that's the problem we actually focused on, because we thought, if we want to make a tow truck for space, how do we do it? How do we pick up an object in orbit? So ClearSpace actually has been, the team of ClearSpace has been working on this problematic for years within EPFL. In 2018, we spun off the company into the project into a startup that we founded in January 2018. And during the year, ESA issued the first tender for a mission to remove a space debris. We participated to this tender process, and in competition with 12 other industrial teams. And after a lengthy tender process at ESA, we signed the contract for this first mission in November last year. Today, ClearSpace is about 35 engineers, mostly system engineering and different experts of different fields: robotics, sensing, machine learning for pose estimation and different technologies we need for the navigation, and then a lot of system engineers that actually do the integration, the assembly of the complete platform. And then obviously program management. We have a team of industrial partners across 8 different European member states, including companies such as Airbus, EAWAG, APCO Technologies here in the Canton de Vaud, Sideral in Neuchâtel, Deimos in Portugal, or OHB in Sweden. There's quite a few. There's about 20 companies that participate to this mission. The concept of this mission is relatively simple, right? It's really, if you want a minimum viable product of a mission, a space mission, to pick up something and deorbit it. So what we're going to do is place our servicer, which is sort of our tow truck, into an orbit at 500 kilometers using a Vega launcher from Arianespace. It's going to be placed at 500 kilometers, which is quite low on purpose, so that we can do all the commissioning in an orbital environment where if something fails or doesn't work, satellite gets back into Earth orbit, into Earth atmosphere, and burns up relatively rapidly, to reducing the risk of producing more debris. During the commissioning, we're going to test all the system one by one, make sure that the complete platform is a green, is a go, everything works. We will do a couple of robotic tests to make sure the complete operation can be done properly. And then we will be waiting and phasing to align with the orbits, with the orbits of the Vespa upper part you can see on the upper left side, which is a payload adapter for Vega launcher. ESA has a couple of those in orbit, and we're going to pick up one to demonstrate the complete value chain of what a capture and removal in orbit could look like. Once we aligned with the orbit of the Vespa, we will go up to the operational orbit where we will operate a rendezvous. The difficulty we have in this orbit is that in this mission is that we don't just have to place a satellite in orbit, which is the case for most missions. We actually have to meet with another object in orbit. This means you have to find a way to get close to it and end up a little like we saw in the video of the NASA capture of the Intelsat satellite. We have to go to proximity and then do proximity operations. Once we close, after a ranging period where we get closer and closer to the target object using safe orbits, once we are close, we're going to inspect the object, bring back some picture, demonstrate we pick up the right one, and then collect quite some information from space and execute the capture after a green light from ESA. The capture is going to be autonomous, right? Which is necessary. You don't have visibility of your satellite all the time. So the more autonomous your operation is, the better off you are, also in terms of future costs for recurring services. So we're going to execute the capture and then essentially open up the arm and bring the object inside, as you saw in the previous video, inside of the space and close down to make the capture. Once the capture is done, the first thing we have to do is to do a configuration of the stack, which means we have to align the center of mass of the object we just captured and the chaser and the servicer. Because as soon as we do the capture, we have a new center of mass, and we have to make sure that if we want to do propulsion, we push through the center of mass, because otherwise we don't produce a translation, but a rotation. Then what we're going to do is slow down the object until both of the chaser and the object will return into Earth's atmosphere. But this is just the beginning of the story for us. Our ideal case is obviously not this baseline. This baseline is necessary because there's so much complexity in a mission like this that we have to address the problems one by one. Our objective is to go toward reusable services, right? What we would like to do, what ClearSpace tries to build, is the capacity to reuse a platform like this or a service like this, and to execute multiple captures and the removal, eventually do more operations in the future. So there's more services and operations that can be done once all those technologies are integrated. And this is really what we're looking at. And then when we look at the space servicing industry, it's an industry which has multiple verticals, right? The active debris removal is the first one, what we're working on. But then there's further types of services that are possible and already existing. For example, transport and logistics. Bring a satellite in the right orbit. Or it can be mission extension, like what Northrop Grumman demonstrated with MEV, which essentially uses very similar technologies, or in the future, repair and construction. All those for us are ways to improve in terms of sustainability the space operation. In the case of mission extension, you can reuse, instead of just wasting a satellite in orbit, you can reuse it for a few more years and launch less satellites. So you have all those different kind of verticals we're looking at. And what we believe is that our objective is to set up a company that is able to provide that kind of services, have the core technologies and the industrial network to implement and operate that kind of missions. To finish the presentation, what I wanted to share with you is what really animates us. What is, if you want, our profession of faith. We think that removing man-made space debris is the responsibility for our generation to make sure that the future generations can continue, benefit from space technology and exploration. This is why we do it. This is why we wake up early in the morning and work late at night. And this is why we're actually working that hard to make a first mission a reality. Thank you very much for your time. I'd be pleased to answer any questions if we have time for that.
Thank you, Luc, for showing a way out of the dilemma. Although it's a start, it's a very important start, I think. Now, for timekeeping, we are already in the next time slot now. Would you be available after the next short talk for discussions, shared discussions of the space debris and night sky? Yeah?
Sure.
Okay, so then we move on to Nikolai, and then have a shared discussion of this section of the conference. Nikolai,
hi everybody.
Okay, yeah.
Hi everybody. Well, thanks very much, Andres, and terrific presentations this morning so far. Really exciting and interesting to hear some of the ideas and sort of the latest understanding and proposals to address this problem that we're all facing. So, if you allow me, I'll share my presentation as well and take us through what we've been working on with several of our partners, of course. And how this can also help address the challenge. So, the space sustainability rating. I think many of you, or at least some of you, would be familiar with this concept. And we've actually just had a workshop a couple of weeks ago on the sidelines of the European Space Agency Debris Conference that went into the latest updates and the status of where we are right now. So some of you perhaps have joined us. So this is maybe for some of you who are not familiar, going to be a little bit maybe of an introduction. And for some of you who've seen this, maybe a bit of a refresher, but I won't go into too much detail. Technically, I think the importance is in the concept, the idea, and how we think this will help address the challenge that we face. So as a small introduction, I help lead at the World Economic Forum, the Global Future Council on Space, and also work on sort of broader space issues at the forum. And in the council term from 2016-2018, we came up with this notion of an idea to create a rating, right? That basically measures an operator, a manufacturer, a launch provider, how they sort of look and how their mission takes into consideration and addresses the issue of debris. And this is really came out of of the idea that at that time already the debris was becoming a really key issue for the sector. And this was the idea to say, well, the guidelines are going to be difficult to create, or any formal guidelines. There are obviously, as we've just heard, a number of sort of guidelines that help advise. Not everybody follows them. So how do we maybe go at it from a different angle? How do we incentivize really different stakeholders to look at orbital debris and to promote mitigation of orbital debris in a different way? And so this was how the notion came about. And then in early 2019, we announced a collaboration with European Space Agency, MIT, so their space-enabled research group at their media labs, University of Texas at Austin, as well as Bryce-Tech, basically announcing this partnership to develop the SSR. And this is the work that we've been doing for the last 2 years. So what do we mean by space sustainability? Well, we basically want to ensure that the space environment is going to be usable for generations to come. Again, I think we've heard this idea and how we basically why this is important in the previous conversations this morning. But we want to avoid basically losing the capability to use the orbits that are very valuable to us for all the services and benefits they provide. And I think we're all familiar with those. And of course, as we grow more into space and more activities are planned, we want to make sure that we actually don't prevent ourselves from maximizing and utilizing and taking advantage of all these new capabilities. So not just using the orbits for satellites, but actually also going through the orbits. Again, I think this was mentioned previously, that if we have too much debris, it will be more difficult to go through them and beyond, whether it's to Moon, to Mars, or other missions beyond. So the rating does build on existing concepts. So from the UN COPIUS, but also the long-term sustainability guidelines. And it really sort of is you can think of it as a relatively comprehensive set of parameters, right? That looks at how would you design a mission, how you operate it, post-mission disposal, and how all these different criteria help reduce the risk of collision and creation of sort of new orbital debris. So just a quick sort of overview of where we've presented the concept at different conferences and meetings over the last couple of years. We've also had a number of panels. Different participants of this project consortium have been speaking about it. Again, we sort of try to really make it as widely known as possible, because as we hope the rating will sort of become operational in the next year and really start being sort of issued to different operators. Through the work process, we already engaged a number of stakeholders, and I think already have started to have an impact in terms of how companies think about their future missions. Certainly, perhaps not so much current missions, but how already they start perhaps to design the future missions. So again, is a summary of the concept. The idea is to create an incentive to really think of designing missions which are compatible with sustainable operations. And it's really to think of, not just sort of try to position your mission and how effective it can be in delivering results and serving your customers. So from the cost perspective, but also sort of the benefit it brings, but also really have the sustainability component strongly positioned there, right? That it's a sustainable mission. And again, finally, an important topic to say that it's, we don't want to create a new set of guidelines, new set of rules, which potentially could come again in the future, but actually really to recognize the different guidelines currently and how we can promote behavior that perhaps goes above and beyond that, right? And you can see sort of we really looked at the LEED certification for sustainable buildings as an interesting example to how we can sort of give different scores to an actor that decides to get a rating. Again, it would be voluntary, and we thought that really from the beginning, a voluntary sort of carrot-based approach, right? You don't punish bad behavior, you really sort of recognize good behavior, and you really start to reward exceptional or outstanding behavior. This could be an example of sort of a timeline, right? So really, you would have ratings that could be issued early stage, right? So you test what your future mission could, what kind of rating it could get. So in the pre-mission, sort of feasibility stage, then during the design stage, you sort of check in and see how the rating would evolve based on different criteria. And then, of course, in orbit stage, and then after disposal as well, because again, as we know, as we've heard, post-mission disposal was absolutely critical. So do you actually, you can say what you're going to do, but you're actually going to do it till the end. And we're not going to know your mission's final impact on the environment until the very end, until it's sort of disposed of. So the final rating, if you want, conceptually could be issued, for your mission at the end. You can also think of having a certain operator having a rating for a mission, right? And if they have several missions over the years, you can imagine having potentially a rating that sort of a corporate rating, right? That sort of brings together all the ones that have taken place, and the company would want to maintain a high corporate rating. So really want to focus not having any missions that are really bad for the orbital environment. So, and then maybe a small note to say there will be also sort of key tiers, right, which comprise and sort of are based on sort of big key parameters that I'll mention quickly, but we'll also sort of reward through a little bit of a sort of a bonus, if you want, a step indicator that you see on the right here, sort of with additional stars, some of the sort of additional things which are perhaps still early stage right now, but perhaps if you may be thinking about them already, like getting an option from a company like ClearSpace or Astroscale for a future potential deorbit if you don't have propulsion, or if maybe you think your propulsion may run out, or you're already thinking of even just adding physical features to help facilitate a capture of your object, right, of your satellite. So anything that goes in that category at this point, we're looking at this as sort of a bonus mark. And again, as of course the orbital environment evolves, the idea is that we would really see the rating evolving with the environment, with different technologies. So it's not a static rating at all. The idea is really the concept evolves with technology and with how the environment, which we, as we've here again, we expect it's going to get busier. So maybe something also interesting to understand is we have, particularly early on, considered all sorts of different areas of scope, what should really go into the rating. And we have decided that really early on, right now, the pressing challenge is on orbital debris. Of course, you see a number of other elements here. So, impact on our environment through rocket launches. Certainly, there is an impact, and it's a whole other technical conversation there. Currently, this is out of scope, so is spectrum use, and then also areas like, what are your mission objectives? Are you an academic mission versus a commercial mission? Are you providing connectivity, or are you doing something else? This is quite tricky to address, and so right now this is not part of the rating. And then also, while we do include some physical capabilities of the mission to help build a mission sort of index, right, that goes into the rating, different types of materials and shielding right now are not in it. But again, this could evolve in the coming years. And then, I would say that as we sort of maybe also in line with the broader topic of this conference, how can the rating evolve in the future? Well, we could hypothetically say that you could have another space sustainability rating that looks at certainly the environment and how its impact on the atmosphere and what kind of fuel a launcher uses, for example. But you can also think even beyond and onto planetary missions, lunar missions, asteroid missions, and beyond, and to say, well, actually, I really want to ensure that that I'm being as sustainable as possible. And those missions are also done in the most sustainable manner from different angles. And of course, there you have a very different algorithm and different set of parameters that goes into that. So, but that's certainly, I think, is feasible. I think it's something that would be also helpful to think about and to promote sustainable sort of growth and expansion of humanity onto different celestial bodies in a more permanent manner, and certainly when not only in a robotic manner, but when humans go beyond the low Earth orbits. So looking at the parameters that are in the rating right now, then these are basically the 6 key parameters that you see. So we'll look at detectability, identification, tracking. So can you detect an object? Can you actually track it as it moves along? And can you actually identify it as well? Do you know what it is? The mission index, basically number of different elements that go into that. Some physical properties, size, but also where you actually, which orbit you go to. So here you have concept of environmental capacity that goes into that as well. So that's very important, actually. Are you going into a very busy orbit? Well, that makes it actually riskier. Also, active sort of collision avoidance is part of that. Then also another parameter, standards and regulations. Do you follow those? Do you have also, there's a whole separate parameter on collision avoidance and processes. So do you share information? How easily is that available? How easily can you get in touch with another operator, or they can get in touch with you in case there's a potential conjunction? There's a whole separate section because we think that's very important on data sharing. And do you have the processes? Are you part of different associations to ensure that transparency? And then there's a section on data verification as well, because again, we think that it's important to actually verify, because it's a voluntary rating. Is it just you telling us, or whoever's going to issue the rating, what you're doing? Or is it somebody checking you, or you providing some other technical documents supporting your claims? And then finally, the sort of a bonus module will be this external services, which I briefly referred to in the past as well. And there are different ways. So there is, we have a questionnaire right now that we've developed that asks you certain questions about your mission. Again, most of the answers are actually going to be relatively public, not really anything really competitive in there. And then also some qualitative questions in terms of guidelines and other things that you relative to your mission. And as I said before, you will get a tier score, your main sort of where you are based on these, and then you get a bit of a bonus score if you're doing some things which are maybe not critical right now, but which actually we think help or could help in the future as well. So this is a little bit what it looks like. I won't go into each one of the parameters in more detail, just mindful of the time. This is a little bit the weightings. Really, this is the interesting part, perhaps the weightings that you would get. So the verification assessment, the checking is sort of a horizontal line that cuts across the different parameters. And then there is a weighting applied to some of the different elements. Again, this is still under review, but this is sort of our initial assessment as we think, as we look to see how each of those areas is important towards debris and what really makes a difference in terms of mitigation of debris. Again, this is not 100% final yet, and still under review. And then this is a little bit to give you a sense of sort of how we see the different tiers. Again, you could think of, we may stay with this 4, we may have actually maybe one more added, sort of doing the final analysis of, based on some beta testing that we've done with some real life missions, where a different mission may end up. So if you just barely pass the threshold, you get you certified, right? So you sort of meet basic requirements. So demonstrate willingness to increase mission sustainability, and you basically follow current practices, right? And as you sort of go down the list or rise up the ranking, you sort of show and demonstrate higher and higher willingness to mitigate debris, and really doing more, investing more, also financially, perhaps into really minimizing any potential debris creation. So, sort of coming to the end a little bit, you know, the rating, the goal is really to promote sustainability based from the perspective of orbital debris today, right? Again, this could evolve in the future, and we want to really incentivize and promote positive behavior. You know, this is not only perhaps for a little bit of corporate social responsibility and CSR, right? And the company to be proud of how sustainable they are. But this could actually, we think, go beyond it. We've had conversations with investors, but also insurance companies who say this is very interesting for us. We are more and more concerned, and if we invest or insure a mission, or for that matter, if you're a regulator, as this becomes established, you know, the hope is that the rating could really become a recognized symbol of how a company approaches debris, and could have financial benefits as well from the stakeholders that I just mentioned, but also from the customers. You know, we see customers, consumers, but also business customers, consumers on Earth through other terrestrial industries really get more and more concerned about environmental impacts of products that they purchase. And so we feel that this will sooner or later, if not already now, translate into the orbital sector, or into the space sector. And so having something like this could actually give you a bit of a step up versus your competition that actually may not have a rating. So I think I've mentioned some of the modules, you know, and yeah, I won't go into any much more technical description at this point. And again, as I said, we've had a different sort of beta tests. We'll still maybe doing one or two more as we finish up some of the weighting of the parameters that goes into the rating, and sort of calibrate the final score and how that would look like. Maybe a couple observations which are interesting from some of the beta testings that we've just concluded and are still sort of getting some feedback on. So it is interesting, and what we've heard back, that from the operators, manufacturers, when they design the emissions, when they look at the constraints that the rating may impose on them, and how these constraints actually sort of impact the emission, right? So this leads to different ways that an operator can get a good score, a good SSR score. So some of the questions that we've gotten is there more flexibility, you know, from an orbital selection, or whether or not they're not really based on the purpose of the mission, maybe they cannot change their orbits, but perhaps they can share more data or really invest more into collision avoidance or the number of the spacecraft, right? So this is quite interesting to have as feedback. You know, if some satellite operators may want to consider extending life of a satellite or replace it with a new model, how would that impact that mission's rating? And so how would that, you know, those decisions impact the full life cycle approach that considers launch? So launch actually does sort of come into the mission index. So launch is part of the rating right now in a way. How does that affect and impact you if you want to get a rating? And then so we are thinking about some of the other elements here, you know, to ensure that we communicate very clearly what is actually influencing a mission score, right, and what they can do to improve it. And you know, what are some of the key features of a mission that influence SSR? So again, orbital altitude, or if you can change that, what else can you do to improve that? So another important consideration. So I've mentioned the members of the current project consortium. We have an advisory group that's been advising us, providing high-level governance. But we are looking to identify probably in the next days, next weeks, more publicly, an organization that's going to actually take on the management and act as a host organization and really be the lead and home for the rating going forward. And so, of course, this is going to be an important selection. It's going to be publicly announced, and we're working hard to finalize that, and hopefully soon this will be announced publicly as well. So just as next steps, we're in the final stages of development. And really, Q2 to Q3 this year, we're looking to transition to this future home organization. And really, sort of towards the end of this year and into 2022, the future SSR operator will do some finalizations and organizational setup. And of course, the hope is that soon we will really start to offer, the rating will be offered to different operators to acquire rating, display it, and again, the idea is it promotes most sustainable behavior. So that's, I think, a little bit what I wanted to share with everybody. And again, hopefully that builds on some of the comments made by the different speakers, which are all excellent, and maybe addresses a little bit this notion of how can we voluntarily influence the behavior in orbits. We think it's absolutely critical. It cannot be only a stick approach. We already heard there's perhaps a stick approach is not really working. Can there be more voluntary efforts and perhaps a little bit more incentive-based ways to promote behavior to a really problem that's very serious, and that's we feel also that's growing in importance. So I'll stop there and perhaps address any questions.
Thank you so much, Nikolai. Yeah, I had the pleasure to enjoy a workshop where you invited me to. So this sounded for me very familiar now, but very important as well. So we had Thomas showing us, laying out the problems, the challenges we have. We had Luc presenting us a way to clean up or starting cleaning up somehow in the orbits. And we have Nikolai, which showed the concept to how to prevent pollution, future pollution somehow in basic lines. We will use some time of the break to discuss these three talks, and I invite questions to all of the three speakers now. We will later resume our session, but now it's time for discussions. André, do we have questions from the audience? Maybe?
Yes, there are actually by now 3 questions. Let me pick the first one up. That was, I think, mostly related to Thomas Schildknecht's talk by Anka Sterian. Yeah, if I read this correctly, she's mostly worried about the accelerated rhythm of launching thousands of satellites in the next years, especially with the development of more companies who can do that with cheaper prices. So that's sort of the commercial background. Yeah, and she's worried if these two processes are not synchronized and clear procedures and laws created, I think the same thing will happen as in the case of pollution of Earth. So we never learn from our mistakes. Thank you for the talk.
Yeah, thank you for that question. That's really the main issue we are facing right now. And I think Luc has made it clear that we are entering a completely new area of using space. Just imagine you have one launcher with 110 small satellites, and this happens. Each of these satellites would in principle need to be registered, have a license from the so-called launching state. This licensing process takes in account right now does in most cases take into account mitigation guidelines and requirements. But the point is simply that we don't have any, let's say, restriction on the amount of objects you're launching into a certain region in space. We have no restrictions on who is allowed to launch something. The only restriction we have, and which is regulating to a certain extent, for example, in particular in GEO, the amount and the use of space up there is the ITU. It's via the frequencies you need for your satellites. There, it's obvious. Each and every, operator in space needs a frequency to communicate with his satellite, and these frequencies need to be coordinated. Otherwise, we have a full mess. And this is done on international level right now. And the same way we are, we are assigning slots in the geostationary region for satellites. But this is not the case in any other orbit region, and this is the main issue right now. Just give you, apart from the space debris things, if you do your best job in making sure that you are not colliding with somebody else, if you do your best job that you are disposing the satellite at the end of life, still we could face the issue that in certain area in space it's simply too dense that we can do safe operations. So how do we manage the capacity of space up there, for example? If one company decides to use a certain shell in or certain area in space, I mean, they're allowed to do that, both on international level, there's no restriction, and on national level as well. Why should I prohibit the use of this space? But, by the end of the day, it could end up with one company using the area X, another one the area Y, and we are faced with facts up there. And you're right, it's like with the challenges we have with pollution here on Earth. The big difference is really, I mean, if you have if you have pollution here on Earth, in many cases this is kind of confined or loosely confined. It's more like if you pollute the atmosphere or if you pollute the oceans, because that will spread all over the world. And I fully agree with you. I mean, this is why I said we need regulations, and we need them now, because it might be too late if we take not care, not just the mitigation measures and so on, but also the question about how much capacity is up there. And the society needs to decide eventually, and I know this is not sexy at all, but we need to decide if certain type of missions are of a benefit for the society, or if we finally say, no, we don't think the benefit is outweighing the negative impact of a certain mission. How we are going to do that, I don't know. We have to look at other communities like the climate community, how they deal with these issues. They're very, very similar, and the driver behind of that are very similar.
Thank you. We have one question from amongst the speakers. Christian, can you pose your question?
Yes, thank you very much. To Thomas and also to Luke, thanks for the excellent presentation. I'd like to know about the cleanup mechanism. I mean, Luke, you showed us an example how that can work for larger objects, but Thomas, you explained very dramatically that the magnificent or the largest threat actually comes from the smaller ones. Can you explain maybe a vacuum cleaner doesn't really work and it's very challenging, both I would assume technologically, but even theoretically. How could we get ever rid of these small objects? Is there a chance? Thank you.
Thomas, you want to get started, or should I?
I could get started and by simply answering that taking out the large objects, that's not going to reduce the risk for missions or space safety immediately. Taking out the large objects will have a huge impact on the long-term sustainability. Small size objects, that's what you have to care about as an operator. Many of them, depends on the altitude, are going to be cleaned up over time because they're falling down to Earth more quickly than large ones. And the vacuum cleaner is not the solution. We will need something else. We will need, for small size object, we're thinking about using lasers, for example, to nudge them a little bit. It's not about bringing them down, but that's the idea is that apart from active debris removal, we will need another mechanism which we call just-in-time collision avoidance. So that if we have, let's say, 2 inactive objects on a collision course, right now we can just wait and watch the show. So we need to have means to nudge them a little bit so they're not colliding, even large ones, because Luke is going to take out 1 per year, 10 per year, whatever. But it could be that the one he wanted to take out of the environment next year is on a collision course today. So what do? We need this just-in-time collision avoidance, as I mentioned. And the very small ones, millimeter, centimeter is the biggest risk for your missions. No reasonable technological means right now to deal with them.
So we're looking at it from the following perspective. Every small object comes out of a large one, and all the small objects we have up there right now are fragments of large object that fragmented at some point. So if you want to address the fundamentals of the problem, then you have to remove the large ones. You have to ideally remove them before they start fragmenting. At the same time, if we did some development for a smaller object, our first mission was to pick up a CubeSat of 10 centimeters, right? That was our initial plan. And the question will be the economics, because with every single small object, you will have to do a rendezvous if you want to deorbit it using an active method in orbit. This means that you will have to rendezvous with 1,000 small objects or 10,000 small objects coming out of a collision. There's not a problem with small objects. It's the fact that below 10 centimeters, we don't really see them, right? So when you have a fragmentation event, there's a huge amount of really small shards that produced a few millimeter or maybe 1 centimeters or 2 that we actually not able to observe from the ground. And every single collision that happens generates a huge amount of the small ones. And those ones, not only is it really expensive to rendezvous with all of them, right? But you don't even know where they are. So for us, it's clearly, for us, the case is clearly large ones have to be removed before collision events, because this is something that can be done. This is something for what we can build a sustainable use case. The other question, when I met Muriel at the beginning in 2017, the first question I asked her when I saw the curve of space debris and her mission to pick up the Swiss cube, I said, what do you want to do? Do you want to remove 1 satellite? Or do you want to remove 1 big debris or 1 debris of more than 10 centimeter size? Or do you want to remove them all? And she said, I want to remove them all. So we needed a sustainable business case, because you have to finance this and it cannot just be on charity. It's not going to work. We need a sustainable business case.
I fully understand the point, Luke, but I mean, saying this is what we need to do because we can do it sounds a bit like I'm searching for a lost item where the light is, not where I lost the item. I think it is definitely true that we need to do the large, to remove the large stuff as well. But as we learned, I mean, the real problem for the missions comes from the smaller ones, probably. But thanks a lot.
Yeah, that's right. Yeah.
Thank you. Do we have further questions from the audience, André?
Yes, there are several questions actually. Maybe I'll ask one question from Gurpreet Singh to Nikolai. Do you advocate for the idea of weak sustainability where operators can potentially pay a fee to pollute space, similar to a carbon tax, or the opposite idea of a strong sustainability where fiscal cannot replace the environmental or social dimension of sustainability?
Yeah, I think these are very good questions, but I'm not sure I'm not sure we have a clear sort of position on this right now. I think it probably will be necessary to sort of have either some kind of combination of different policies, right? But you would first need to have a proper sort of multi-stakeholder discussion, right? You need regulators to sort of come together, and you need different companies to come together who are really concerned about this and who have vested interest and say, look, what makes sense? I mean, all these missions, right, that we're talking about, they're all going to be impacted. And we already see some of these impacts in the news today, right? So it's in their interest. I think the key here is to ensure that there is information transparency. They understand the different impacts and of what they do. So promoting that transparency, but also promoting that discussion is going to be critical, right? And then perhaps jointly there's going to be a recommendation of, well, how do we actually pay for some of these things? How do we ensure that we either don't pollute more, or we some of the financing, innovative financing mechanism actually addresses and goes to pay for some services that Luke will be offering. I think there are several different proposals out there. I don't think one is clearly in the lead at this point, but financing is a big issue. I mean, how to get rid of all this is a big issue, and so it needs to be addressed. Good question.
Yeah, maybe I have a question to Luc. Well, this is 80-something million you got for the project. It's just for one mission, more mainly, right? So you sketched out how you envision the future of removal to be more like an orbital business, which is where you reuse your removal device. How do you imagine to finance the future, so to say, and of this removal? Do you have any plans on that?
Sure. So obviously the 86.2 million euros for the first mission is mostly non-recurring engineering costs, right? A large part of what we're going to do in this mission is produce technologies, test and validate the technologies that will be able to replicate at a much lower cost. And that's the whole objective behind this mission. So there's a certain number of levers you can actually activate or actuate to bring the recurring cost of a removal down, because this is really, I think, the key of making something that is self-sustaining, is to make sure that you can bring the cost of a single removal down to a price where it's affordable for operators to do so, and where the cost cannot be an excuse anymore to do nothing. So obviously for us, the objective, so the levers you have is mitigate the launch cost. The launch cost is an important cost, the production of the platform, the operation cost, and the reusability cost, right? Essentially, the strongest aspect in this is to make sure that the single platform can do more than one operation. One thing about, so obviously the goal for us is to bring this cost substantially lower and obviously ideally below 10 million per removal. So how low it will be able to go will depend on how those technologies evolve over time. But the first mission cannot be used as a benchmark to determine how much the cost of the service could be. Now, there's just one more thing I thought through this question of whether addressing the large object is basically looking away from the bigger problem, which are the small objects. And I think it's a very interesting question, actually, though I just want to bring back one last point about this one. Is the fact that you can try to address the effects, or you can try to address the cause. This discussion about small objects has one risk, right? It's true that the risk of a collision with a small object today is higher for a space operator than a collision with a large object. The risk is higher, but it might be an argumentation that just paralyzes the development of activities that or could paralyze the thinking or the thought process for activities that can address the source of the problem. And I think this is really how we look at it. And I think this really addresses the question fundamentally. It's like saying, oh, I've got a lot of trash bags in the sea, so I should go and pick them up, right? Or I think, okay, I should stop producing trash bag, or I should make sure that they're recovered in the supply chain earlier on. And I think this is really the question we will have to address in the space industry if we want to make sure that we find a long-term solution to it. Now, to finalize on the question of the cost, yes, the goal is to not sell every single removal at 86.2 million. And that's definitely what we plan to do. There might be some where the cost will be high. For example, if you take MVSAT, this is a massive object. It's 8 tons, it's a school bus, it's tumbling. So it's going to be a difficult mission. So there's going to be some really difficult exercises that are going to be expensive. But if you look at the complete budget of MVSAT, it's I think if I'm not wrong, it's 2.3 billion total cost of MVSAT so far. So having a mission that costs 70 million to remove an object like this might actually make sense, or 80 million might actually make sense. But the objective is obviously to bring this cost substantially down.
Thank you. Yeah, and there will be, of course, I guess, if the space sustainability rating is in place, that maybe offer new opportunities to refinance your services. And maybe until then, you could deal with insurances for to have sorts of when it will be in place and possible to remove that they use the options. I don't know.
I think. Oh, just one last comment about it. I think the space industry has something quite amazing, is that they have a very strong multiplying factor between the number of assets in space and the number of users on the ground. And probably one of the solutions would be to make sure that the users of the service actually support that kind of effort. It's a little like what's done with the carbon offsets, right? When you buy an airline fare, you pay for an airline ticket, you've got the airline fare, let's say $400 to make a flight somewhere. And then you have the little tick box at the bottom that says carbon offset, that many cents. And I think that kind of models are definitely models that should be explored. And I think this really fits into what into the rating approach, saying what is sustainable, what is not, and what the WEF is doing on that side, what Nikolai is doing on that side with the WEF.
Nikolai, did you want to chime in on that?
Yeah, and thanks, Luke, and again, just highlight that it's definitely international collaboration to develop it. So, I mean, I think, look, if we make comparisons with the climate topic that we have on Earth, you know, it's taking a number of years to get the ball actually rolling. I think arguably some would say it's still not enough. I saw recently a statistic that, you know, this sort of the gap that we need to close in emissions by 2030 has, you know, from the big gap that we have actually closed by about 12 or 14% because of some announcements and some national policies that we've seen and corporate policies that we've seen, you know, the last 6-12 months. We're still far away from closing that gap, so certainly more action looks like is needed. I think, but it's taking years. It's this long-term notion, right? You know, what are really the effects for me? It's getting everybody aligned. You know, I think in space, you know, perhaps because there's so many national interests, as again was mentioned, whether military or national security or key data that's required for weather monitoring, providing connectivity to critical industries, climate monitoring, right, which is a huge benefit from the space sector. Perhaps that's, you know, the alarm bells I think have been ringing for a number of years now on the debris, but I think now they're getting really loud, and I think some of those interests which derive value from space will sort of stay, you know, and they have a lot of, I think, weight in some of those decisions, and they will say, no, we need to actually be very careful here, because otherwise we really risk losing the value that we've been able to do, and we can't afford to do that, right? So perhaps, you know, it's in one hand, I think it's as complex because you need international collaboration. Or perhaps on some of the other angles, it could be solved in a quicker fashion. You're not going to solve the problem, but perhaps you can address it and put in the mechanisms to remedy it in a little bit of a quicker fashion. But this is a little bit my personal sort of perhaps thinking. And yeah, we certainly hope the rating could help motivate and incentivize and really showcase the responsible actors. And then, you know, hopefully pull the rest. Not everybody will get and the point is that not everybody will get a perfect rating in the beginning. That's absolutely the opposite, right? The idea is that you really only highlight sort of a few actors who are really good, and then almost maybe 1 or 2 or 3 that are really above and beyond, and that pulls then the whole community, the whole sector into the more greener territory, the more sustainable territory, right? So let's see, but it's an exciting moment right now, and we see how we collaborate and over the coming months, and more to follow soon.
Okay, thank you. We will have 1 or 2 more questions from the audience. André, I guess there are more questions. and then we have the word of greeting from our host and the break.
Yeah, sure. We have actually Guillaume Delannoy just commented that game theory developed at MIT might be of some use to analyze the weight of considered criteria toward the ability to influence private operators, as it did for the telecom market opening in Europe. That was just rather a comment, and then he apologized for not being present now, but he will return at 1:30. There was one more question by Gurpreet Singh, actually to Thomas Schildknecht, but probably it applies to all of us. With space being regarded as a warfighting domain or a potential war theater of the future, can space collisions be seen as a threat to national security? And if this is considered a national security, would this actually help to bring a higher degree, a sense of higher responsibility by national actors, so that there's a bigger pressure to control the production of new debris?
Yes, thank you very much for this question. It is, I think, really an important question. In a nutshell, I would say yes, because the main, I mean, some of these, developments, in particular in the United States, have been mentioned this morning, and many of these were driven actually by concerns of the military that their assets, which are absolutely vital for them, that their assets are threatened by the increasing space debris environment. And so a major, driver, for example, for the United States to help others by having bilateral agreements and providing them conjunction messages, what they call, they're providing operators, space agencies with messages telling them, hey, we see that you are on a potential collision course with an object. Could you analyze that and perhaps do an avoidance maneuver? This is, or originally was really mainly driven by the military concern, or concern by the defense community, that they're really threatened by this, by the proliferation of space debris. So I think this is certainly having a big impact. But there's also a but. That's only, addressing part of the problem and part of the, only a very narrow part of the full picture. And we can definitely not, let's say, rely on, let's say, the military is putting enough pressure onto states, which will then try to regulate. We have that. On the other hand, we have that the new space, and we have what we have been talking about all the time this morning. This completely new area of operating in space, which can not be controlled by simply, as I mentioned several times, simply applying mitigation measures. But for sure, some of this, let's say, openness to share data is, for conjunction assessment, collision avoidance, is definitely driven by the military requirements of protecting their own space assets from space debris.
Thank you. Yeah, any last questions from the speakers or from the audience to this?
Actually, there was one comment about this carbon offset pricing idea. Lois Miro wrote that these pricing mechanism policies usually have to be progressive, and they're characterized by an important time lag before being effective. For instance, the price of carbon cannot be raised so abruptly so that actors can have the time to adapt. But regarding space debris, since thousands of constellation satellites are already planned to be launched in the following years, isn't it too late for this kind of policy? So that might be a worry here.
maybe everyone can give a short answer of our three speakers, and then we hand over.
I don't think it's too late to put in place that kind of policy, because this kind, if you put that in place, this is a way for actually paying for cleanup, right? If you do that, and if you by the time that the cleanup is actually in place and able to do it at an industrial scale, it's going to take time as well. So I think it's never too late to take an action that can actually have an impact. That's how we look at it.
Thanks.
It's not too late. I'm absolutely with you, Luc. It's not too late. But cleaning up is the last, that's the last thing in the chain. I mean, before we clean up, we need to do traffic management. We need to know where the objects are. We need to do collision avoidance. And somebody has to finance that as well, because nowadays, none of the commercial operators is fully capable of doing the full picture of doing the traffic management. So we need incentives to finance that part as well, to finance the entities which will do conjunction assessment and collision avoidance maneuver or collision avoidance assessment for the commercial operators. Some of them will be able to do that, but not on their own. I mean, they need to be, that needs to be seen as an entire worldwide system, and somehow we have to finance that, and we need the corresponding incentives to do that.
Yeah, just from me, 30 seconds. I agree with both points. I think it's better late than never is probably the right statement here. We absolutely need to start doing things, but we have to start doing things on all of these aspects, right? So debris removal, better traffic management and approach, and better situational awareness, better international collaboration. I mean, these are all sort of urgent things. We really have to tackle it from all different angles. Otherwise, it's going to get so bad that it's going to be very difficult to then solve it, if possible, for decades to come. So I think we really need international collaboration and to really think about this today.
Yeah, thank you. Thank all three of you for your presence and for your thoughts and for your presentations and the discussion. We will continue with the workshop soon. We will have now a short greeting by our host, Mathias Wirth. Professor Mathias Wirth is the head of the department where this project, the Ethics of Planetary Sustainability, is situated. And yeah, some housekeeping remarks will follow after these greetings from Mathias. Floor is yours.
Yeah, thank you all of you, dear participants of the workshop on Planetary Sustainability 2021 at the University of Bern. It's my pleasure and honor, obviously, to be able to welcome you on behalf of the Faculty of Theology and the Department of Systematic Theology and Ethics. And I'm, by the way, only responsible for the ethics, so I'm not the head of the whole department. I'm glad that despite this pandemic situation, you are keeping your sights not only on urgent matters, but also on important issues, accepting the call and Dr. Andreas Loch's invitation, whom I would like to thank gratefully for his excellent work. The question of sustainability and ethics is always a question of responsibility in the sense of a beyond. It is about responsibility for the things that do not pose an immediate concern, but are not less relevant, such as future generations in social precarious situations, etc. In today's workshop, you will be able to proceed of a certain beyond, reflecting on yet unaddressed planetary responsibilities that are not as distant as they might first appear. I'm incredibly grateful for your thoughts about the technical, normative, political, and economic questions in this context, and for your far-sightedness, and I wish you all great success. Thank you again for coming. Thank you, Andreas, for your involvement, and I wish you all a great and safe time. Thanks.
Thank you for your kind words. And we had now deserved, all of us, a nice short break. which we will resume earlier though. So those who want to listen to the introduction, which we missed for technical reasons at the beginning of the workshop, it will be 1:15. And you just stay on the platform, the speaker. So remember that you need to join another Zoom. And yeah, thank you again, Matthias. Thank you everyone for this insightful morning, and see you soon again.